Referees.
Sir,
Hello, sir. Good morning, sir.
good morning, sir. Very good morning to all. On behalf of RV College of Engineering, Department of Physical Education and Sports, in association with Sports Engineering Association of India, I cordially invite all for the online inaugural function of Sports Engineering, Technology and Management. I welcome you all for this wonderful event. For this inaugural function, Master of Ceremony will be done by Rakshita Sharma D, Biotechnological Department, and she is also a very good sportsman. Over to Rakshita D.
Thank you so much, sir. Good morning to everyone here. I, Rakshita Sharma, feel privileged to extend my warm welcome to everyone present here. On behalf of the Sports Department, RVCE, for like the National Online Seminar on Sports Engineering Technology and Management. Before we get started, I would like to thank each one of you for being here with us today. I would now further request Raghavendra sir to address everyone with a welcome speech.
Good morning, one and all. To uncover your true potential, you must first find your own limits, and then you have to have the courage to blow past them. Greatly said by Picabo Street, the Olympic medaler. Technology has been quietly transforming the world of sports for years, while technology has facilitated perfectly the legitimate advantages from equipment to medical treatments and to nutrition, which have improved the standards of the sports. It has simultaneously opened up a new dimension, a new means of cheating that is against the ethos and character of sports. Is technology just a decisive factor, entertainment factor? Is technology ethical in sports, an entertainment factor, or altogether a changing factor of the status quo of sports? Ladies and gentlemen, I Major Raghavendra C, the Senior Manager for Estate and Facilities, Rashtriya Vidyalaya College of Engineering, take the privilege and honor of welcoming the esteemed chief guest and distinguished dignitaries today. The enlightened speakers would enlighten us about the new technology and sports engineering, how exactly a technology can manage your sports. Inaugural function of the Sports Engineering Technology and Management, organized by the Department of Physical Education, Rashtriya Vidyalaya College of Engineering, in association with the Sports Engineering Association of India. I thank you one and all. I take this honor of welcoming our esteemed chief guest, Dr. Pintu Modak, the Senior Physical Officer, Physical Education, BITS Pilani. I also welcome our respectable principal, Dr. K.N. Subramania, Principal of Rashtriya Vidyalaya College of Engineering. I also take the privilege of welcoming Mr. Anil Kumar Suravaram, Managing Director, Great Sports Tech Hyderabad. I welcome Professor Madishankar Das Gupta, Professor Mechanical Engineering, BITS Pilani. I welcome Dr. K.P. Venkatesh, Assistant Professor Mechanical Engineering, BITS Pilani. I welcome Mr. Rajesh Javalkar, alumnus of RV College of Engineering, Bangalore. Ladies and gentlemen, thank you for blessing us with this occasion, and we are more to hear your enlightening thoughts about the new technology, sports engineering. Thank you one and all.
Thank you so much, sir. On behalf of everyone, I would thank you for the warmly gesture. I would request Dr. Vishwanath sir to take the pride and honor in welcoming our honorable chief guest.
Dr. Pintu Modak. Pintu Modak is currently has had a fascinating career, has been actively for seminars, presentations, published books that are based. After completing his bachelor's and master's in physical education, completed his PhD now Bali University, Bali. The year 1991, who obtained a diploma in sports coaching, gymnastics, at Kolkata. Mother is currently a founder secretary of Main awards include Ratna Award by Indian Academy Writing, first place for paper presentation in the second place paper in 21st fourth and fifth of paper presentation seminar has been rated 25 presentation till date holds significant I think member of has been appealing for this examination of PhD. As an author, six of his books, quotes and exercises have been published till date. Hope that you can continue to contribute to the world of sport as we have done so far. Good to have you here, sir. Over to Mother, sir.
Thank you, sir. I think there is some network issues. I would request our honorable chief guest to address the gathering. Sir, can you hear us? I would like to thank everyone for putting in the effort to be in the seminar. And this is a really great initiative by the sports department.
I couldn't understand. I could start or not. Uh, Good morning, everyone.
Sorry for the inconvenience, but we would like to take this time in appreciating the sports department of RVCE in organizing this national seminar. And I would request everyone to wait for a while so that our chief guest would join in for the meeting. Hello. Am I audible?
Am I audible?
Yes, sir. Yes, sir.
Thank you. Thank you. Good morning, everyone. Respected Sir Dr. K.N. Subramanian, Principal, Architects, Engineering, Bengal. Invited speakers, Professor M.S. Dasgupta, Mechanical Engineering, JTS Pilani, Rajasthan, Mr. Anil Kumar Saravaram, Grad Sports, Mr. Rajesh Devalkar, is alumnus RB College, Bengaluru, and Dr. K.P. Venkatesh, Mechanical Engineering, BITS Pilani, and all dear participants. And my dear Dr. Vishwanathan, Director Physical Education, RB College, he is also the active member of our Sports Engineering Association, India. When he has shown his interest to hold us this seminar on sports engineering, I was indeed excited. And when he called me day before yesterday and said I was made the chief guest, I was really not excited and comfortable. However, it is an honor for me to be here today in the National Online Seminar organized by RB College of Engineering, Bangalore, in associations with uh, Sports Engineering Association India. The Sports Engineering Associations India is incepted to provide a sustainable platform for engineers and sports scientists to interact with the athletes and coaches to promote sports technology, particularly in India. There is a very simple equations. Unless we have engineering in sports, we cannot improve the level of playing in India. As we know that, our level of sports at the international events like Olympics does not mean we have not improved. We have improved a lot, but not as per other developing countries as they are going very fast, much ahead in sports technology. And this is only because of their engineering involvement in sports performance. Sports is a multidisciplinary approach of which engineering is one of the most important disciplines, and it is without doubt that engineering and technology is playing an important role not only in improving the performance of an athlete but also in making sports more entertaining yet safe. There are huge the numbers of technology being applied nowadays in various sports. And to name a few, we have categorized the technologies applied in sports into four distinctive engineering disciplines, namely, we can say material engineering, computational modeling, instrumentation, as well as design and ergonomics. Our engineers are well capable, we know very well, and can well connect their academic expertise with sports and help in improving sports performance, particularly in India. But we are very much ignorant in connecting engineering with the sports development intrinsically. So the reason behind that, Sports Engineering Associations India is an important platform is adopted for engineering fraternity to work for sports in India. Sports engineering is where engineers conduct studies designing sports equipment and facilities for players and help coaches for improving performance and injury reductions. Instead of going further, I must allow our next invited speakers to speak about further about what sports engineering and what it deals with. With this, I conclude by saying that Indian sports needs budding engineers like you to see sports grow better. I thank you, Dr. N. Subramanian, Principal, for having such seminar, and also my thanks for Dr. Vishwanathan, Director, Physical Education, and his team for their efforts in arranging the seminar very expertly. I wish you all the best. Thanks. Thank you all.
Thank you so much, sir. Thank you for enlightening us with the importance of the sports engineering. Now I would request Dr. Malay, sir, to do the introduction of our first speaker for today.
Good morning to one and all. Anil sir is the founder, MD of Great Sports Tech, incepted in 2004, and now the leading sports infrastructure company in South Asia. Under his leadership, Great Sports Tech has executed some of the most prestigious and innovative sports infra projects over the last 17 years across 8 countries in South Asia and recognized for their highest quality products, innovative technologies, and professional service. GSL was awarded as India's top 100 SMEs out of over 49,000 nominations. Best Professional Service in Sports Award by FICCI, the Scotch Achievers Award, etc. His achievements were recognized with Emerging Entrepreneur Award by CII. He was featured in the Young Turks program in CNBC TV18 and other business program on ET Now, NDTV Profit, and in over a dozen business publications like Inc. Entrepreneur, Smart CEO, etc. He is a regular speaker in various forums like FICCI, TIE, CII, and at various seminars on sports and entrepreneurship. He is a life member of TIE CEO clubs, a member of the National Sports Committee of FICCI and CII, and a founder director of Sports Engineering Association of India. Anil sir was a national level sportsman in athletics and handball. He also achieved state and national honors in NCC. Anil sir is first generation entrepreneur with engineering and MBA degree and later an executive development program from Kellogg School of Management. He worked at Wipro Technologies and Ramco System in India and the USA before incepting Great Sports Tech. Thank you.
Thank you, sir. Good morning, Anil sir. You have been a great inspiration to a lot of professional athletes like us. I would request you to honor the meeting.
Good morning, everybody. Thank you very much for the invitation to be here, and of course, thank you for the invitation as well for the introduction. And first of all, I'd like to congratulate everybody here who are attending the event today. Actually, congratulations for the whole nation in a way for what India has achieved, having had our best Olympic year ever. And I think this is a great start to what will be further improving over the subsequent Olympics. I think for the first time, I'm seeing that sports is no more a small segment of following. It now has a general mass awareness. I was surprised that, my father was calling me after Neeraj Chopra's every throw and telling me the distance he has thrown. He's following Aditi Ashok's golf exploits over 4 days. Many people, relatives who otherwise wouldn't have known much about sports. I think we are all very fortunate to be witnessing the first time, at least in my years, again, like it was mentioned earlier, I've been in sports from my school years, and I'm seeing for the first time that there is a sports culture that's coming into the whole nation, and it is not a small set of 1 or 2% of the people who are into sports anymore. So I think all of us here who are trying to exchange our knowledge and experience, and in turn spread that out across to our wards or trainees or students, and to the sports fraternity in general. I think what we are going to be doing every session like this is going to help India over the next few Olympics and create many more champions. So I think we all owe ourselves a round of applause and a good congratulations. So please do keep up the good work. I particularly want to thank Dr. Vishwanath for inviting me to speak on this session. And of course, always very privileged to be associated with the Sports Engineering Association with Professor M.S. Dasgupta and Dr. Pintu Modak. Very happy to be part of that. So incidentally, I also take a small little bit pride that, when he mentioned about me being a national sportsman, it was actually in junior nationals where I'd won in javelin. So it's very nice to see that javelin, finally, people wouldn't even half the population never even knew what javelin was. But it's nice to see that it's now prominent. And I was reading in the papers today that August 7th will actually be declared as the National Javelin Day. So it's interesting. So very nice to see that Prime Minister is involved so deeply, not just in about those who have won gold, but when he has called and consoled our hockey teams, even when they have lost. I think that's a great sign. I personally do not know any other instance of a president or a prime minister calling a team and consoling them when they have lost. And this is a great, remarkable event. I feel that we are not just celebrating victory alone, but we are celebrating the effort. We are celebrating the sacrifice. We are celebrating the hard work. And we are celebrating the fact that they have tried. And I think that's a remarkable milestone. India will get better from here on. People won't only ask whether you've won only an Olympic gold medal, but they will also see whether we are doing better and better as a sports nation, even if it is at some other smaller event. So I wish India does really well, and maybe 2 or 3 Olympics from now that we will be in the top 10. I'm very confident of that. Having said that, I'll go into a brief presentation of mine. I know about 30 minutes is given. I'll try to keep it to maybe 20 or 25 and keep a few minutes for any questions. Trying to see if I can do a screen share. Somebody may need to help me with the screen share, please, in terms of how may be able to share the presentation online. Can someone guide me on where I may be able to share the presentation, please, in the controls?
Sir, in the bottom, after the video, there is a share option, is there?
Yeah, but that's disabled for me. So if it can be enabled, I'd appreciate it.
It's enabled, sir.
It is grayed out. I can see that's why. Okay. I'm unable to click on that share option. If I can just be, if I can just be given that option, please.
Sorry to interrupt, sir. Could you please mail
I can't hear you,
the
Rakshita.
same presentation to us? Maybe we could arrange by sharing.
Yeah, you're audible now. You want me to email it to someone, you're saying?
Yes, sir. Yes, sir. If you could email it to us so that we could share it here currently, and we will
Actually,
check upon the technical issues.
It's a very large.
Yeah, Anilji, just a minute. Rakshita, can you please come out of your presentation mode so that the Anil can take up the share button? I think.
Sure, sir.
Yeah, that may be there. It's too large a file to share, so it will be difficult.
I think now Anil can take up the share button will be enabled.
Yeah, it's not yet showing, but I guess that may be a good possibility. Yes, I think there can be only one presenter, and
So
it probably
could
means
you
to just make me as the presenter. Not yet, but
Yeah, still it is from the.
Sir, now you can share it, sir.
Not yet activated.
Anil sir?
Yeah.
Anil sir, is it audible?
Yeah, I can hear you. Yes, please. Yes.
You can share your screen, sir.
No, I'm unable to share. That's why I'm saying that share button is still disabled. So I need to be just maybe designated as the presenter for that.
Yes, sir. Anil Kumar, presenter.
Only one person can share.
Sir, you are the presenter, sir, right now.
Yeah, whomsoever has already presented, he has to come out of the presentation mode. It's not at the.
Yeah, whoever had introduced me, I think maybe that person had shared the screen. Maybe that person who had introduced me may need to. Or you could temporarily make me the host or something.
Right.
It is.
Or you can make Anil as a host or co-host, or you can do that.
Okay, I think I may be able to share now. Let me try. Is it showing that the file is loading? Can someone confirm, please? Yeah. Is it visible?
Yes.
Sir, it's visible, sir.
Okay, good.
Yes, sir. Yes, sir.
Sorry. Okay, wonderful. Sorry about that, and it needed some time for me to figure out. Okay, so I'll, as it says, we'll try and talk about the synthetic sports surfacing, and I think I request others to kindly mute their phones, please, for the benefit of all the other participants. Everybody kindly check that your microphones are muted. Thank you. In terms of the importance of synthetic sports surfacing, I think there is a resound coming somewhere, please. I'd request once again everybody to please mute. Thank you. So we'll touch upon the criticality of why a good sports surfacing, is an important element towards how a sports person training can progress in terms of better performance, similarity with what they will be competing on at a later stage in a more professional environment. Obviously, good sports surfaces also take into account injury prevention. They have many safety aspects that go into it, conformance to global standards, and certainly the best performance basis to compare. So we'll see the criticality of why this is, and therefore, over a period of time, over the period of a few slides, I will explain why these surfaces are very well thought through. And I'll not spend too much time on, a little bit background about our company that's available on the website. So I'll just leave it to your interest whenever you may want to see that. So this is, what I was referring to in terms of, you first have to determine what exactly you need as the facility. Many people, whenever they talk of a sports facility, they immediately want to say, I want to do a world-class facility. I want to do Olympic standards. I want to do, really at the highest level. Many times that is going to cost so much more money and really serves no purpose. Many times politicians feel very happy to say, okay, we will do a 50,000 seater stadium or 1 lakh seater stadium. For what? I mean, if you don't foresee having many events there where you're going to utilize that 1 lakh seating capacity, it is just vanity in terms of trying to have 1 lakh seating capacity just to boast of, whereas 80% of the investment would have just gone into creating that seating capacity, which you may not use more than 1 or 2 times a year. So many times we have to, at a recreational level or amateur level, at a university level, we have to determine what exactly are we looking to provide. Maybe all we need to provide is, a good playing surface that is sufficient enough. Sometimes, for example, in synthetic surfaces, you may have something that are international event, like Olympic level, which you may not necessarily need at a practice level. And you have some surfaces which are synthetic, but of reasonable and sufficient quality while coming at a very optimal price. So these are some factors that you need to consider in terms of when you decide to do some sports infrastructure. First, sit down and think, who is going to use this facility? How often are we going to use it? How is it going to be a good investment optimization? None of us will have endless amount of money. When we go to our vice chancellor or when we go anywhere and say, I want, X number of crores, you will always run into resistance because you may be asking for something much beyond what you really need. But if you are able to plan out to say, okay, with X amount of money, I'm able to create Y number of sports facilities, which will benefit our students and they will be able to play different sports. And it gives them a semblance of what they are likely to see and require for better progression and for better competing, that's likely to get more acceptance. So there are, of course, important things from an engineering standpoint. Most of the fields, as you are aware, should be aligned north-south. Almost all the outdoor fields are aligned north-south, whether you take a cricket field, a football field, hockey, athletic tracks, all of them. So it's important that, the area that you have, it is available in a north-south direction. Otherwise, you will have difficulty in getting the certification, whether from IAAF or from FIFA or FIH. By the way, IAAF, as all of you know, is now renamed as World Athletics. It's WA. It is no more IAAF. They generally allow maybe like a up to 10 to maybe 20% deviation from the exact north-south. And this is, of course, as you know, to prevent the rising or setting sun from coming into the eyes of players or goalkeepers, or all of those likely distractions are eliminated. You have to, of course, get into the survey. You need to be making sure that it's not with some existing trees or boulders, that has impact on the finished surface. If you do not treat such areas properly, you will then have undulations after 6 months or 1 year, and then all your investment may go waste if you are not taking care of the proper soil sub-base preparation. Of course, there are many other things to go into by way of, globally, you can find that online there are many resources available in terms of the drawings and designs and layouts. I'll come to a little bit in depth of that. If you are talking about an indoor sports facility, the number one factor, of course, is that it has to be pillar free. There should be no pillars, obviously, in an indoor sports facility, and that makes the cost go up. Secondly, you have to consider the height of the building, because whether it is badminton, where typically at a national level or
Excuse
even
me,
most
sir.
international events. Yeah.
I'm sorry to interrupt. Your screen has been just presenting on the same slide. If you're changing it, it's not
Oh,
yet.
I have been changing to 3 or 4 slides already. Yes.
Yes, I figured maybe you didn't realize it, so I thought I'm sorry to interrupt, but I think
Is it? No. It's important to know. So are you still seeing the very first screen where it says
yes,
presentation on?
yes, yes, sir.
Okay. Let me load that up again and see if I can get that to transition this time, because I went over already 4 or 5 slides. Are you seeing the next slide now? Are you seeing any other slide, or still the first
No,
slide
sir,
itself?
not yet, not yet.
Okay. Let me close it and try and come back. Let me try this way and see if it transitions.
Yes, sir. Maybe if you put it as like the slideshow from beginning and like shift the slides.
Yeah, I mean, let me see if I can do it here. Is it visible now?
Yes, sir. Now it's visible.
Okay. Okay, I'm sorry. Then maybe I'll just skip these slides. So, okay, I'll just very, very briefly for 10 seconds touch upon some of the slides that I'd already gone through. So, like I said, objective of the facility, you'll have to, determine what is it that you're really looking to do. Recreational, amateur, are you doing for training purposes? Is it for competition and certification? So, these slides, again, I can share these slides later, but I hope it is making more sense now from what I was speaking earlier of how you have to determine what exactly you're looking to do. Most people think they always have to build an Olympic standard facility. Not necessarily true. You'll be spending 5 times more the amount when you actually need something that may be sufficient to generate interest in players to come up and play. So this is one point I want to touch upon. This is the point where I was talking about, most of the fields, you need to be careful about the orientation and doing the site surveys and soil test, all of that. This is the slide I was in at this time when I was speaking in terms of the indoor facility. As you can see, pillar free and, the height, what you need to take in. I was saying, you could have 30 feet for badminton, but international Olympic events need 40 feet. But for that reason, don't go ahead and create a building of 40 feet height, because with every additional foot height, your cost goes up dramatically, disproportionately high. So always look to think and plan optimally. That's the right way of creating sufficient facilities that are not overboard. Like I said, nobody will have endless amount of funding available. Yeah, you'll have to also see what kind of flooring, whether sometimes you may need, what is the sub base, and above that, are you going to have a wooden floor? And when you have badminton, are you going to put in, for example, the Yonex mats or, the leaning mats, any other such cushioned mats? Or are you going to have cushioned PVC as the overall surface? Many, many factors to consider. These are general points I'm saying. Of course, you have to consider lighting, whether it's natural or artificial lighting, and ventilation, air conditioning. In badminton, as you're all aware, if you do not provide the well-controlled air circulation, it causes a lot of drift, and which can cause a disadvantage to one player and an advantage to another player. And usually the top players are extremely sensitive to how the shuttle may misbehave if the draft of the air is not particularly good. So you have to be very careful of that. So with that preamble, I'll just get into the various surfaces, and I'll try to really breeze through some of the ones that most of you may be aware. I'm starting with some really very simple ones, and I'll finish with relatively newer, slightly more complex ones that some of you may not be aware. As you see here, this is the typical, what people call a synthetic course. That's a very typical term people use when they see synthetic is anything that is man-made is synthetic, but somehow acrylic course, what you typically see in many schools, colleges, clubs, corporate campuses, which are acrylic courts, are incorrectly referred to as synthetic courts. But of course, they are very good. They are inexpensive. A typical court may cost maybe like 15 lakhs or so. And it's not unusual to have maybe more than one court. And those courts are typically good for both tennis and basketball. You can generally define a size that can accommodate both. However, people use it for volleyball, which is not technically correct. Volleyball is generally an indoor sport and is played on softer flooring, whereas you saw recently the Olympics, people may be diving and sliding, and which you cannot do on these acrylic courts. They're very hard. In fact, they're even called hard courts. The bounce is higher, and it will cause injuries if serious volleyball players who may be diving or sliding, fall on these courts. Also, the extent of jumping or leaping, when you are playing basketball, volleyball rather, they may cause injuries. These courts are much harder than it should be. And of course, badminton, people do use it because they may not have an indoor facility, but badminton also ideally is an indoor sport, but these can be used. They are relatively inexpensive, they're fairly long lasting, they're all good, but it cannot be used for any non-sport purpose. That's one limitation with these courts, because if you don't wear the right shoes, you can keep scraping away the acrylic coating. So that's sometimes a problem. In this, you may keep hearing again 2-layer, 3-layer, 8-layer. Even here, many times people say, yes, I want 8-layer system. Many times it is unnecessarily more expensive without actually delivering a proportionate benefit. The cushioning that you may get from an 8-layer system is certainly no match for the cushioning that you would get from just good shoes. So don't look to necessarily do 8-layer and very expensive thing. Anything from a 5-layer system is generally sufficient. Again, this is just my suggestion. Most of you are, physical directors and, into sports infrastructure or other decision makers. Of course, this is a brief process that some of you may be aware. Typically, these are built on bituminous or, what you call asphalt surfaces, where, you have to do a lot of site preparation, get the asphalt in place. There is leveling, there is manually laid asphalt, because these are too small for sensor pavers to come in. And then you have leveling slurries and all that. And then you get into doing the surface coating. But people also do it on concrete surfacing, but just that concrete is more susceptible to expansion and contraction, which leads to more cracks. So generally, it is better to do on bitumen, which is also a little softer for the foot when you're jumping, playing on it, compared to concrete, which is obviously much harder. So that's a little bit on synthetic acrylic courts. These are typical pictures that you may see in many places. You could even have multi-sport court marking there, just to make your facilities more utilized by multi-sport. Then you have polyurethane surfaces, which you could be both indoor and outdoor. Polyurethane, they come in thick liquid actually. So by the way, Rakshita, please let me know if you see that the slides are not transitioning. I hope you're seeing this indoor red color slide at this time.
Sure, sir. Sure.
Sure. So the polyurethane surfaces, these are laid what is called cast in situ. Cast in situ means they are laid at site. So they come in again in 2-3 layers. There's a rubber shock pad below, and then the polyurethane is spread with, like a squeegee. Then it is evenly spread. It is like a self-leveling liquid also. And once it hardens and freezes, it becomes an excellent surface to play. However, of course, we also have these indoor polyurethane or polyvinyl chloride, PVC, I will come to that in a second, that may come in rolls. Some of you may be more familiar with the rolls that are used, but Generally, the finish with the self-leveling liquid is better. Outdoor also it is used, and generally these are considered technically better or superior surfaces to acrylic coating, which we saw a little earlier. They are longer lasting, they are crack resistant, better cushioning, all of these, and also used outdoors. So many benefits, but it's of course more expensive. So you have to choose carefully based on your budget. There are many layers to this, but broadly you just need to understand that there is typically a 8 millimeter to 10 millimeter rubber shock pad below. That's the important thing for you to just keep in mind. I'll not go into too much detail in the interest of time. So I'll just transition through, please. You could have, of course, polyurethane indoor coats, like we saw a similar picture earlier. And you could have hybrid PU. Nowadays, there are products where it is a mix of polyurethane and acrylic. So that's the reason why it's called hybrid. So it is not as expensive as the typical full polyurethane coat. It is not as hard as the acrylic coat, and this is a good mixture where you get reasonable cushioning and all the benefits of a PU system, or most of the benefits, but without as much cost of a PU system. So these hybrid PU coats are now very popular for all outdoor sports where acrylic coats used to be typically used. Having mentioned briefly about hybrid PU, in the interest of time, I'll not not go into detail here, but please suffice it to know that certainly more and more coats in the country are transitioning from acrylic coats to hybrid PU. Next, we'll come to interlocking modular tiles. Again, some of you may be already familiar. These are used both indoors and outdoors. These are, tiles, as you see, they are interlocking tiles and they come in various colors. In fact, you also have wooden color finishes on top. These are portable. They also do come with FIBA and ITF kind of certification. So there are many FIBA level events that happen on these. The benefit with these interlocking, like this is an example of the wooden finish. It is not obviously wood. It is still polypropylene, but just there is a veneer on top that is giving a wooden finish. So what you see on the right side may look like a wooden coat, but it's actually polypropylene. And here it has a maple finish. These are interlocking tiles, and the benefit is that you can use these indoor surfaces for non-sports as well, and of course multi-sport as well. And they last very, very long. Typically, their life is well over 20, 25 years. It's that resilient. They're fairly expensive. May typically be, if it is not a wooden finish, it may typically be, for example, anywhere from 250 rupees a square foot, and with wooden finishes can go even to 600 rupees a square foot. Outdoor also, they can form an extremely good option. And where, like the slide here shows, you could make like really very attractive looking coats and also do a multi-sport marking. So typically where outdoor coats like this, you can also use them for non-sport events. So if it is a school, we have done some places where it's a large hall where they use it for sports, where they use it as a cafeteria, and where they use it also for any cultural events or parent-teacher meetings or annual meetings or something. So if you have an indoor hall, these tiles are again good to consider because it's multi-sport and multi-purpose. This is, for example, of how you could probably look to design an indoor or even an outdoor facility where multiple sports can be accommodated. I'll share these slides so you can just get an idea of what I'm saying. Maybe 8 to 10 different kinds of sports can be made available. This is just an example of how it may look outdoors. This is the indoor cushioned, like I was saying earlier, cushioned PVC flooring, polyvinyl fluoride flooring, which comes in rolls. So you may just need a concrete base. These are not meant for outdoor though. These are purely designed for indoor use. So this is something that may come in very handy for indoor. They are good cushion levels. You have very thin ones starting at maybe as little as 3.5 millimeters. And then you typically have 5 millimeters, 6, 7 millimeter, and the highest one at around 9 or 10 millimeters. Usually the top 2 millimeter only is the PVC layer. Below that, the thickness is only indicating the cushion layer. So this is a cross section of how the surface is for a 6.5 millimeter. It is indoor, ideal for many sports, very safe, good cushioning. injury-free. So all of these benefits. So many indoor halls tend to have this. Like I said, people may even go in for the polyurethane flooring, which comes, like I said, cast in situ and not necessarily only the PU. So these are examples how you may even have portable rolls which are used for badminton. Like you see an example here where you may have that rolled out only when you need. Of course, you have various colors and logos that you can do. Then we come to some of the turf related options. Obviously, all of you are familiar with hockey, and I think especially in with the Olympics just having passed, you would have seen a lot of blue color turfs. Just to give you an idea, hockey field is typically FIH size is typically the playing area is 91.4 meters long, right? And you need to give 5 meters behind the goalpost on both sides. So that adds another 10. So the length is generally 101.4. And the width of the playing area is typically 55 meters. And on the width, you need to give a little safety or runoff area. Unlike 5 meters in the length, here you need to give only 4 meters on each side. So that makes it 63. So typically, you will therefore see a hockey field. The turf is typically 6388.4, something like that, roughly 6,400 square meters. So this, and of course, there are details of how the base is constructed. I will, not spend too much time on that, but suffice it to say that there will be slopes. Incidentally, for hockey, it is sloped on in various directions, both in the length and on the width. So, and there are, of course, levels of how it is done, layers of how the subbase is built, but mainly it is a bituminous surface. And you have, of course, have blue color turf or green color turf and all that. And FIH, in terms of product, there is something called FIH preferred supplier. Some companies, maybe 5 or 6, 7 companies globally, are somebody who are designated by FIH as a preferred supplier. And then there are some companies designated by FIH as a certified field builder. Incidentally, our company, Great Sports Tech, is also one of the globally certified field builders. There's a very elaborate process to do the bituminous base. Again, in the interest of time, I will just skip that. But you can see how they obviously come in rolls, the turf. Then they are laid. First we do a shock pad of 15 millimeter to give some sufficient cushioning, and then we do the turf laying on top and the lines that are inlaid. And usually you finish off with a field like this, and then you get a certification called FIH certified global category or something like that. This is a example of a field that we have recently done for South Central Railway in Secunderabad. But yeah, there are also while most of us know of hockey fields which are water based, and water based is, again, for you to understand, it is more to prevent injury, because the hockey turf is a little bit harsh turf and very stiff fiber. And when people slide or dive on it, it causes some skin burns. So the field is generally sprinkled or sprayed with water, with the water guns you saw on the first image. That is mainly to prevent the injuries. So that is typically, that's why it's called a water-based system. You can see in this photograph how we have water guns on the perimeter, and then they have a throw reaching till the middle of the field and therefore able to keep the whole field moist. However, you have less expensive now sand-based systems which don't need water, and where there is a, within the turf, there's a different, slightly softer kind of turf where we put in the sand, silica sand as an infill, and these are less expensive to maintain because you don't need thousands of liters of water every day. And again, people have a misconception whether that water is needed for daily watering of the turf. It is not. The water-based system, the water is needed only when you play. So if you don't play for 4 days, you don't need to, water it. Usually the watering is done before the game and during the halftime, just FYI. I'm not getting into comparison of the water-based versus sand field, but suffice it to say that sand field is less expensive. They are also FIH certified. We have done a sand field system for Don Bosco in Mumbai, and there are 3-4 other FIH certified fields in India. They are also a good option to look at when people may not be able to afford a water-based system. Then I'm talking about the synthetic turf for football. Again, most of you are aware, because natural grass may not sustain the heavy usage, and therefore in most of the cases you end up with very hard and bare ground without any grass. for as a sidelight, typically elite stadiums worldwide actually use their, like, Wembley Stadium or something. They of course do it on natural grass, but they are able to keep it in good shape because they conduct no more than one match a week, and usually it is no more than one match per 2 weeks. They usually have 12 to 15 practice grounds, and that allows them to certainly use the other fields, and only during the important matches they tend to use the main ground. Here is anyway the cross section of how a synthetic turf field is. So typically between the turf fibers, there is an infill of silica sand and rubber granules. Again, I'll not go into great detail, but suffice it to say that that provides the cushioning, and that provides the stability for the fibers, and the top 3/4 inch is generally left open without any infill, and that's why when you see it from the top, you will not see any infill. But that's how the cross section of the synthetic turf for football or any other grass-based sport, that's how it is there. Yeah, as you know, obviously there's no maintenance. It's a multi-sport and multi-purpose, all-weather. It lasts typically 10 to 12 years. So that's similar. That's the typical highlight. I'll not go into some of the details that may be overwhelming for now in the interest of time. Again, even the sub-base for here, unlike a bituminous base, it is a sand-based or rather an aggregate, crushed stone-based sub-base. And like I said, you don't need any watering, but there is a facility we give for the draining of rainwater when there is excess rainwater. So that's how that is done. I'll not go into comparison with natural grass, but yeah, this is a quick few pictures on how there's survey, excavation, there's leveling, there's compaction of the ground, then there's perimeter drain, there's trenches to be cut for the drain pipes, then we lay a geotextile, then there is aggregate, like I said, the crushed stone, 40 mm jelly, like people call 40 mm, 20 mm, 10 mm, all of that. And then you reach a finished base, a crushed stone base, and then we have the low rolls that are laid. They come in various panels. A typical football ground will have about 25 rolls, and the typical infill, this silica sand and rubber granules that I'm talking about, typically a football field will have 250 tons of infill that has to be brushed into the fibers. And then, of course, you end up with a good finished field. Then there is a FIFA team that does many tests on the site, and that's how they arrive at FIFA certification based on that. This is the synthetic turf for multi-sport. Again, the same synthetic turf could also be used in smaller schools or other facilities. They use it, sometimes, though it is not actually designed for athletics, but people do do that in a circular or oval fashion and mark it with white lines with white paint and make it seem like an athletic track with a mini football field inside. They use children's play area or volleyball courts or cricket or any of these as well. So that's there. Athletic tracks, of course, again, something that all of you are familiar with, but I'll just give you a little bit more detail. I'll not go into the dimensions. All of you are aware that it is typically 400 meters. And there is a certain lane width like 1.22 meters. If you have, you can do, if you need to get an IAAF certificate, or what's now called a WA, World Athletic Certification, a minimum is 6 lane and minimum is 1D, just for you to be aware. You don't need to go 8 lane, and certainly you don't need to go 10 lane, which is only required for Olympics and all that. And you don't need 2Ds. And in 1D, you can accommodate almost all the sports and the throws, jumps, everything. And based on that, you can calculate based on the area that you have. But a typical athletic track, a 400-meter synthetic athletic track may typically be in the region of maybe 5 to 7 crores. You can do smaller if you do like a 6-lane track, maybe at around 4 crores, 4.5 crores. And there are a couple of important varieties. One is called full pour, which is more expensive. Again, you may not need it. And the less expensive one is actually called sandwich system, which is sufficient. In Kerala, for example, almost all the athletic tracks, they prefer only the sandwich system. They are also World Athletic certified. They can even get a Class 1 certification. And in fact, they have been used even for the national games in Kerala 4 or 5 years back. So again, there a decision can be made that you don't need to necessarily say, I want the best in the world, and unnecessarily put in a lot of money when you could optimize your investment. So you should always keep thinking on those lines. You can, of course, have athletic tracks in blue color as well. We have done in Sports Authority of India at the Calcutta location and few other places, Nagarjuna University in Guntur, so some places like that. Like I said, there will be full pour system or sandwich system. I've talked briefly about it, so I'll just rush through in the interest of time. I'll skip that part. Installation, again, you need to build a bituminous base just like you would do for a hockey field, but it will have its own slope. For example, in an athletic track, you will typically have a slope coming in from the outer lane into the inner lane, typically just less than 1%, typically maybe 0.75% slope inward towards the inner drain, just to ensure that there is no water standing. You get class 1 or class 2 certifications, those are there. Here again, we've gone over some dimensions for a football field or a hockey field, international. These are available online, so you can certainly look up those. I'll come to the last point. I'm sorry I'm overshooting my time, but this is the last important point which I thought I'll touch upon. Obviously, everybody knows, there is synthetic turf, and then those who don't have synthetic turf have natural grass. But in the last 10, 12 years, another form of turf has become very popular called hybrid turf. And as the name indicates, it is a mix of synthetic turf and natural grass. Almost all the World Cups from 2010 have been using the hybrid turf in all their venues. So whether from South Africa through Brazil to Russia and now upcoming in Qatar, all of them have hybrid turf. So as the name indicates, like I said, there are two ways. You can either do a injection system where you are actually injecting almost 2 million fibers into the ground to a depth of about 20 millimeters. And then you are actually growing natural grass where the roots of the grass will intertwine around this synthetic fibers. And the surface becomes a very resilient surface where the bottom fibers, the synthetic fibers will come up only 1 centimeter above the ground, and the natural grass will come up about 2 to 3 centimeters above the ground. So you're technically playing on the natural grass, but the resilience is provided by the synthetic fibers as a support to that natural grass fibers near its bottom half. So this is, Grassmaster. It indicates where it is an injection system. You also have there are many benefits to hybrid turf. I just wanted to briefly introduce you to the concept. What happens is this is allowing, natural grass, the roots are able to grow much deeper, and therefore they are able to have a much more resilient and more disease resistant, and overall allowing more games to be conducted and faster recovery as well. So you have a better system overall. So this is hybrid turf that I thought I'll just touch upon. Within that, like I said, I was talking about the injection system where you have, fibers going down like that, 20 centimeters into the ground, 20 millimeters. And then you have the Playmaster, okay, here are some examples of where they have Grassmaster, but this is the other one called Playmaster, where it actually comes in the form of rolls. So you have synthetic fiber that may come in the form of rolls like you would for a football ground, and then it has enough gaps within the synthetic fibers where the natural grass is actually planted, and there's a certain way. There is a sandy base, what is called as the USGA base. USGA base, where it defines the kind of sand, the aggregate, and the geotextile and the piping network, all of that, and how the natural grass and the fibers from the synthetic turf will coexist and create this hybrid turf solution called Playmaster. So this is what is done, where the Playmaster turfs are first laid, and then maybe I'll try and see if I can. Okay, I can't play the video now, but that's fine. So that's basically I wanted to touch upon. I'm sorry, in the interest of time, I'm rushing through, but important to probably stop here. And again, I don't know if the time allows for any questions, and I'm happy to just close here because of the fact that I was actually supposed to finish maybe by 10:40 or 10:50 rather, and it's already close to 11. Sorry about the glitches when we got started, but this is where we are. So this is the overall summary of the kind of sports surfaces that are happening all around, and whatever is new in the world. Pretty much covering maybe 80-90% of what's needed typically conventionally. So I hope that covers almost all of it. So, Rakshita, back to you in case there's any questions. I can take that. If it is not, we can move on to the next session, please. Thank you, and thanks very much, everybody.
Thank you so much, sir. I think being a sports person myself, stepping onto the court almost every day, I almost had no knowledge about this and feel very honored to sit here and gain a lot of knowledge. And I'm sure a lot others in the meeting also. So to everybody else, if you have any questions, you can surely type the questions in the question box so that we all could see it and sir could possibly answer. And thank you so much, sir. Thank you so much.
Thank you. Happy to be there.
Yes, sir. And on behalf of the Department of Sports Department from RBC, as an honorable gesture, they're providing the e-com certificate for participating in the seminar. And thank you so much for giving us the valuable information.
Thank you. My pleasure and honor. Thanks very much for having me.
Yeah. So I suppose there is no much questions, so we will be moving ahead with our second speaker. So I would request Promino Charles sir to give the introduction about our second speaker.
I'm audible, Rakshita?
Yes, sir, if you could be a little more louder.
Yes, Rakshita, thank you very much. A warm
Yeah, thank
greetings
you.
to all the panelists and all the attendees here for this webinar. At this juncture, I would like to introduce Professor. I'm audible? Okay. I would like
Yes,
to
sir.
introduce Professor. Yes, sir. I would like to introduce Professor Manish Shankar Dasgupta. So we are glad to have you, sir. Sir will be presenting on the title Sports Technology and Biomechanics. Gupta is presently the head of the department, Mechanical Engineering, and also is the coordinator for Internal Quality Assurance Committee in BITS Pilani. Sir pursued his bachelor's degree in Mechanical Engineering from NIT Silchar, and further, he did his master's degree in Mechanical Engineering from Jadavpur University, and finally completed his PhD from BITS Pilani. Dr. Dasgupta mentored several innovative initiatives earlier. So the well-known among all them are initiatives like Rural Transport Vehicle, the design suitable for negotiating road with ruts and uneven roads, and Hyperloop India, contesting at SpaceX Hyperloop, pod competition at TAMU and California, reconfigurable VTOL, vertical takeoff and landing, Garuda design for the Vertical Flight Society Control USA, University Rover Challenge at MRDS, UTHA, USA, etc. Dr. Dasgupta has primary research interests in environment-friendly technologies, specifically in CO2 transcritical system for HVAC. He is in review panel of several Elsevier journals like Energy, Refrigeration, Fuel, etc. He also pioneered introduction of sports engineering as a subject of study at BITS Pilani and organized the first international conference on the same subject in India in collaboration with IACA. And he also has published many papers, many journal papers in peer-reviewed journals, and has delivered key notes addressed at conferences within India as well as abroad. He has executed several funded research projects from various funding agencies under the Government of India and also an industry-sponsored project. Dr. Dasgupta is recipient of several awards, including Young Scientist Award from Department of Science and Technology, New Delhi. So we are happy to have you here in this live webinar, and the mic is over to you, sir. Thank you, sir.
Thanks, all of you. Good morning. Thanks for the elaborate introduction. So we are basically teachers, and then that's the better introduction for us. I had, okay, now I think the share button is activated. Let me try to share. So I hope it is visible.
Yes, sir. It's visible.
Yeah. So my topic may look a little more academic. Thanks to Mr. Anil, who presented very practical session and on sports surfaces, etc. As in the introduction, it is mentioned that about the sports engineering course. So in BITS Pilani, you have introduced a sports engineering course for mainly for the engineering and the science students. Sometime back, about 2.5 years back, and then every semester we are able to train about 50 engineers, that is undergraduate students from various disciplines in this curriculum, and then people are taking also a lot of interest. And my expectation is that in this in this presentation, or rather through this presentation, I will be able to encourage some of the listeners, some of the young, very potential engineers to come to this field, study this, and then work for India. Okay. So good morning again, all of you. It's really my pleasure and privilege to be presenting in front of all of you in this temple of learning called Army Institute of Engineering. And I appreciate very much the hard work put forward by Dr. Viswanathan in organizing the event. My regards to Professor K.N. Subramania, Principal RV College of Engineering, and Major Raghavendra, the Senior Estate Manager. With permission from Chief Guest and other learned speakers and dear audience, I would like to start my discussion. I understand we are a bit late in the schedule due to some initial glitches, but let me try to cover it up. So I belong to BITS Pilani, that is introduced, and also from Sports Engineering Association, which is a non-profit organization listed or rather registered with the government to promote the cause of sports and engineering applications in sports. So use of technology in sports, just a minute please, there is some, yeah. Use of technology in sports is increasing, that we have seen in our recent exposure to Olympic performances and then presentations. The essence of it, or what is the focus, is basically maybe we can find out a couple of key points. One may be performance enhancement, that may be the basic intention of technology intervention in sports. The others can be injury prevention. Mr. Anil has adequately pointed out that thing. The other one, which is very important for a country like us, which is vast country with huge population, is talent identification, because talent identification is very complex process, and then in which automation and other things can go on, because very experienced talent seekers or coaches cannot go around to each and every schools and identify talent at the young age. So technology can help us in that. And also, of course, the other end, there are few sportsmen, and then there are many spectators. So to make sports more enjoyable for both the sports person as well as the spectator, that is also technology plays out in a great way, as we have seen looking at Olympic sports and other sports, sitting in the comfort of the home. Okay. The scientific understanding of human movement pattern is one of the main part in which we will focus on to, in which biotechnology plays a role. The performance measure, how do you measure the performance and then compare the performance? The analysis of the performance, you have to make a comparative study and then find out what are the glitches or shortcomings and then try to improve them. That is of course by the coaches, but then the technologies playing behind can help there. The design and ergonomics of products and instruments that will be used by the sports person during their training as well as during performances are very important. Understanding of mechanical, electronic, computer science, and of course biotechnology is involved in this. Wearable equipments, the use of that is increasing in fitness field particularly. data analysis and computer-wise data analysis, and of course entrepreneurship, which may be very, very important for a budding engineers. Right from school days, we can try to observe simple human motion or bodily motions and in sports, and try to explain them in terms of our own understanding of physics and mathematics. That can form very interesting case studies. Okay? India is not as such as very sporting nation, but then possibly these sporting events which are going on at various places, and then beaming of that to all households, and then increased awareness and more emphasis put on by the government machinery are helping it. But then I hope this will this will help right from the young age people to appreciate the sports, that it is not very different. So sports engineering as such is not something out of the world, but an application of your own technical knowledge that you have learned through your maybe mechanical engineering studies or civil engineering studies or chemical or electronics or computer science, etc. And your learnings in the sciences, and try to solve problems which the sports persons faces. We may not be at this point, like we means the engineers at this point may not be much aware about the problems faced by sports person. That is where the sports engineering organization association plays a role to bring forward the sportsmen and engineers in one platform to discuss their problem and try to find solution. If you look at other related fields like sports science and medicine, they are much more well developed in the sense that they originated early, whereas sports engineering is more of an evolving field. If the young scientists and young engineers would like to know about what are the research opportunities and research going on, so I just try to put them in certain buckets which are very, very prominent. For example, materials engineering is one very prominent area in which sports engineering related research is going on. The presentations made by the previous speaker, Mr. Anil, focused on materials, that is the materials for synthetic materials for sports surfaces, which is one angle of the materials. And then, of course, computational modeling and then computer-aided analysis, etc., plays a very important role. You, on the flick of a button, you get a lot of statistics that you have seen in cricket sports or things like that. So those are computational-oriented research, which is going on. Instrumentation are a very, very prominent field of research at present, in which several fittable instruments, Fitbits, and many other things, and then also health monitoring devices which are there. And also you have seen, as soon as somebody, a batsman swing the bat and then hit a ball, a lot of other statistics comes out immediately, which what speed the ball was flowing, what speed the bat has struck it, or what angle, etc. So all those are based on certain instrumentation. Design, and I think our next speaker, Dr. Venkatesh, will focus more onto this part. Design and ergonomics plays a great role in terms of mechanical engineering can play, in which design of apparel, which may be what the sports person wear or what they use for training. Okay. If we look at material, there may be racket sports, a lot of material-oriented research is going on. We have lightweight bicycle, artificial tracks, functioning, very, very functional shoes, safety equipments like crash-proof helmets, etc. These are a few bits of the research that's going on. Computational field, we have aerodynamic studies, data analysis, visualization, machine learning, and so on. In design and ergonomics, we may see a lot of research going on in performance enhancement, safety, industrial design, standardization of parts, and so on. And of course, optimization of various shape, size, and in terms of material uses. Instrumentation in terms of quantifying the data and safety, recording new kind of data, recording the complex biological signals, and all this are part of it. And also feedback system, which can give us a lot of good, valuable information for the coaches and the athletes, and also sometimes to the spectators. A term may be quite confusing sometimes for newly coming people into sports engineering. Technology in sports, is it ethical at all? If you look at two teams playing, let us say football, one of them enabled with good shoes and then spikes, and then another nobody plays nowadays, but then earlier the barefoot playing, even Indian team played barefoot. So obvious advantage is there for the people who are or the team who has the apparel. So is it ethical? So the ethics behind it has to be understood well, and then it is also a moving or improving concept. So if we look at this very old model of sports person playing in old Greek Olympics, in which two players we can see are doing some wrestling. If we look at this, the striking thing that we see, they are bare-bodied. Okay? So why they are bare-bodied? Because even a piece of cloth in their body can either enable them or hinder their way of the sports that is played. So it was that strict. Okay, it was that strict. But then we now have moved a lot from that state, and we can have, of course, even today, some apparently conflicting signal in terms of what is ethical and what is non-ethical or cheating. So let us take some very quick example. If we look at the world records in pole vaulting, right from 1840s and 2020s, we can plot. Okay, 2021 is not plotted. We see that the earlier sports, the pole was made of bamboo, and there was certain height around 10 to 11 feet, and then there was bamboo pole introduced, which is more supple and could be was lighter, so a longer pole could be used by the sports person, and then that increased their general height of jumping up to 15 to 16 feet range. And then came a small range where metal like aluminum, etc., were used, and after that it is fiberglass, and then a lot of improved kind of fiberglass which is going on, which has improved the general height to about 20 to 21 feet. So it has almost doubled or more than that from the initial stage where wooden poles were used. Now, these are the world records created, and these are allowed absolutely, and then not considered to be cheating. Okay, because essentially the technique or the effort is put by sports person themselves. Whereas if we look at another chart very quickly, it is about men's 200-meter freestyle. This chart has to be read in a reverse way because the vertical axis t, or the second, as less the time as it is good. So there is a red dot that you can see, which was in 2009, wherein a very specially body covered suit were designed for the swimmers by Speedo, and that reduced the time scale to 1.42 1 minute 42 seconds for the 200-meter style, but then this was later deemed unfit or declared non-ethical practice, because the advantage that the sports person was getting was by reducing the friction between body and the water, and then by covering the body, so it was deemed unfit. Okay, so this kind of somewhat apparently conflicting signals are there, but then technology goes on. Technology is progressing. Remember that technology is working on both the sides. If somebody tries to cheat in a game, technology is there nowadays. For example, goal line technologies, etc., which is there aiding the judges also. Okay, so which is also improving. So it is both ways. There are many very celebrated technologies which has come into the sports. For example, Hawkeye. I will not go into detail. Most of you may be knowing it. Goal line technology, wherein the whole of the ball has to cross the line, so it is a difficult decision for the referee. So a multi-camera, multi-sensor system is used to ascertain whether it is a goal or not. Similarly, the HANS device has saved lives of hundreds of people in adventure sports. Similarly, nowadays the wearable computers, of course it is not called nowadays wearable computers, but wearable devices, which are helping out a lot of sports person in the field. So very quickly, we can look at the achieving great height in jump. Maybe that's the example of a performance enhancement. How we can explain this in terms of simple physics. So if you are standing somewhere and try to do a standing jump, we know that if we take the human body as a lump parameter model, whatever height you throw the body center, that is the CG of the body, is the amount of effort you put. So in this picture at the bottom, you can see that in all these examples, the CG is kept in the same height, but the body is contoured in a certain form so that you are able to cover maximum and maximum height. Okay. So it is the, I mean, when you curve your body and lean forward and then cross the hurdle, that's famous Fosbury-Fluff technique. And these are simple analysis right from the school days. You can look at the sports body movements and then try to analyze yourself how this is happening and what is the rationale behind the same. We can take one more example. For example, somebody jumping, a kind of a standing jump with one hand up. As you put your two hand up, your CG has moved up in the body. So by same effort, you will climb little lesser. And if you fold your leg also, you will move your CG up in the body. And then you will actually, with the same effort, you will jump even lesser. Okay. So these are certain things which can be explained with everyday physics, and that you don't really need an engineer or some training for that. You might have observed the athletes move in a certain fashion, very funny it may look like when they are doing certain exercises. They cover the barrier or lift their body in a certain way where the head height remains almost same. Why they are doing so? Because they want to preserve their energy. By stretching the leg and covering by they can circum a higher barrier while doing lesser amount of effort. The path of CG is very small, whereas the height of the head remains almost in the same case. Okay, just to preserve the energy. You can have, you can try to look at around you and then try to do yourself some of the movement and then find out such movements and then try to explain. I hope the slides are moving. I have not really got a feedback.
Yes, sir. It's going on smoothly, sir.
Thank you. So working with human is the prime aspect of sports engineering. When in engineering, you mechanical or electrical or civil, you work with certain instruments or machines. But in sports engineering, we basically try to work with human. That's the difference of it. Okay. And there are other related terms like sports science and etc. Sports scientists generally look at what is happening inside the body, and sports engineers generally look at what's happening outside the body, body interaction with outside. It may be the sporting surface, it may be the dumbbell barbells, it may be the other sporting instruments, etc. That's what we look at. So definitely for being a sports engineer, you need to know about the human body, because human body is the one which will be your machine and with which you will be working in a when you work with a human body. So with a background of engineering, we generally try to understand the human body in terms of engineering. So in engineering, very first classes, you will be taught about mechanics, and you will be taught about lever system and so on. So there are lever systems in human body which we try to understand. And we understand that the lever system moves, or the motion is by the muscles essentially or mainly. Okay. And the muscles are basically like strings. So a string you can attach to something and you can only pull it. You cannot push that object when a string is attached to it, and then you cannot push the string because it is supple and then flexible, it will not push it. So for a limb movement, basically you will always need two set of muscles. One to fold the finger or the hand or the leg, and another to straighten it back again to the similar previous position. So two set of muscles will always work out. Minimum two set of muscles will always work out to having the movement of a joint. Okay. So most of the skeletal muscle, because that's what we are interested in sports, because there are other muscles, of course, but the skeletal muscles are at a considerable disadvantage. I mean, God has made us in this form. Thus, the external load that you can lift, let us say you are trying to lift a 100 Newton force or the 10 kg weight, the muscles actually endure more amount of force, because that's because of the typical lever system with which the human body is made of. Okay, so we know about first class lever. We need not go into detail of it. So we can have a lot of examples of first class lever in our body. So this is a hand in which you are trying to push the wall or certain things, or catching a ball. So Fr here is the force that the ball is applying in your hand, while the force that the muscle is enduring is the Fm. And then knowing the dimension of the hand or the skeletal structure, you can always simply do the calculation and find out what is the force endured by the muscle. Second class lever. Yes, we have second class lever in body also, and when we try to understand the body in terms of machine parts. And so in the leg, in the plantar flexion movement, you can have a second class lever example. So the Fm, which is the muscle force, and Mr, which is the moment arm for the Fr force, and the Mm is the moment arm for the Fm force, that we can simply take moment and equate, and then find out what is the unknown force either in the muscle or in the Fr. Similarly, we do have example of third class lever also in our body. So this is another example of a third class lever in which you are trying to lift a load, and Fm, which is the muscle force, you can find out knowing the other dimension, of course. And these dimension, of course, has to be known, which may differ from people to people. It may differ due to racial reason. It may differ due to your height. It may differ due to your age, and so on. Male-female disposition is also there. Okay, so these are certain things to be known, and then we can calculate what are the muscle forces coming, and you can also calculate what is the load you should lift, or things like that. While we try to understand the muscle action and motion, we need to understand the plane of motion. There are three planes mainly. We will not go into detail of it because it's a kind of a 30-40 minutes of discussion. We will not go into detail of that. The axis of motion we need to understand. We need to understand the degree of freedom of the joint and the range of motion. It is not that muscular or skeletal joints are certain like a ball and socket, and then you can have a 360-degree motion. That's not possible, okay? Because you cannot fully rotate your hand. There are ranges of motion, and then within range of motion, certain position you may be able to apply the maximum amount of force, and in other position you may not be able to apply the maximum amount of force. That we can see in, let us say, simple hand wrestling you are doing with your friend. So when the hand is kept vertical with the table, you can apply a lot of force, but when your friend has put you down almost to the table, you cannot basically apply the same amount of force. Okay, so range of motion is important. So other things which are important are the types of muscle. In sports engineering, we are mainly concerned with skeletal muscle. The other, which are non-voluntary, like cardiac or smooth muscle in the stomach, we are not much interested. It's the skeletal muscle which gives basically the motion. Okay. Within motion, there can be eccentric contraction kind of motion. When the load we are trying to put it down, there is the eccentric kind of contraction happening. It can be isometric action where there is no movement. You are simply holding the weight in the location, and then another can be concentric type of motion wherein you are lifting the load. Okay, so these three different types can be analyzed separately. And then we also have a signal. As you know, the muscles are activated by the brain signal, which are basically electrical signal and chemical signals. And then a bit of the smallest quanta of signal is basically called fused tetanic contraction, a bit amount of contraction. A series of such signals comes and your muscle contract, which is controlled by the brain. We also have very, very important terms like isometric and isotonic. If we Look at yoga exercises wherein you make some posture and hold yourself there, and then muscles are stretched. So that's basically isometric. Whereas if you are doing exercises with weight and other things, the motion, exercises with motion, that's basically you are doing the isotonic kind of exercising your muscles. Joints lead to the stability of the skeleton. If you put the skeleton together without the body, it will basically crumble and fall down. They don't hold together. So if for engineers to try to understand the joint, which may be more of a medical field, but then we engineers try to understand the joint in terms of two bone parts coming together and having a congruent surface which is matching. The surface in between, there is a small gap which is filled with some synovial fluid at certain amount of pressure, which may be called as atmospheric pressure. The term may look a little odd, but then that's how it is named. The joint is in position by the action of certain actors like ligaments, which keep them together, and the muscles, which put them together and keep them in equilibrium. So these health of these ligaments, health of this synovial fluid, and health of these muscles are very important to understand the joint stability and the joint motion. Okay. So if we look quickly at types of joints, there are fibrous joint, which are not very important for us, which is there in our skull. There may be cartilaginous joint, which is also not very important. Which is most important for us in sports engineering is only the synovial joint, which are freely movable with the help of brain signal, and then you can control them. Okay. So within synovial joint, we may have types which are maybe hinge joint. For example, in fingers, we can have ball socket joint, hips and shoulder. Remember that these ball socket joint may not be similar to a machine ball socket joint where a unlimited amount of motion may be there. But in body, unlimited amount of motion may not be there. There will be certain range of motion. There can be pivot type joint, which is available in neck. There can be gliding type of joint, which is available in wrist. There can be saddle type of joint, which is common in thumb. There is chondroid type of joint, which may be available in spine, spinal cord, and ankle, etc. Okay? So these are brief pictorial of those joints. Now these pictorials are developed mainly keeping engineers in mind. So I'm just guessing most of the audience in today's session are from engineering and science field. They may more instead of putting a medical figure, these may make more sense to them. So kinematic analysis, all engineers have done. So typically mechanical engineers, we can have a closed kinematic chain, like when you are trying to do some exercise that is thrown in the top figure, or it can be open kinematic chain when you are dangling your feet and then trying to twist it, etc. So in closed kinematic chain, many muscles are involved in certain synthetic way in which all the muscles are toned. Whereas if you want to focus around building a certain muscle, then it is the open kinematic chain kind of exercises that are recommended. So you can easily make human body measurements and make this 4-bar kinematic chain and use your own formula that is there in solving the 4-bar chain, or use some softwares which are also available freely, and then analyze this. Okay, you can also simply look at the cycling exercise and then look at, try to analyze it as a 4-bar linkage, simple 4-bar linkage, and try to analyze this in terms of the various angles, and you can find out how much force or effort is put in the leg. If you are, let us say, tasked with the task of designing certain bicycle for long distance running, the task will be basically to see that the effort required is less and less, and so you can design the arms of this one so that the effort required by the leg is lesser, and accordingly position the bicycle in a different way, and the length of the deltoid arm in the bicycle, and so on. Similarly, if you want to design a mountain bike where suddenly a lot of effort need to be put with the leg, you may have to design it in certain way that look at the ergonomic aspect, at what body angle the human being is able to put more amount of effort, and then look at it and then design it accordingly. So these are quite possible without much of training by engineers. When you look at muscle action, 3 more points are there, and agonist, antagonist, and synergist kind of muscle actions are there. Agonist, very briefly, is the driver basically, which is driving the motion. Antagonist is kind of opposing it, because a sudden motion from one side muscle pull, the joint may become unstable. So the other side muscle basically supports it. And synergistic kind of do not participate directly in the motion, but then is helping it. I'll make available this, I've already made available this slide, and then it can be shared with the interested participant. They can go through it and then for other reading. We can look at the very, very important joints like knee joint or any other joint, and then look at their biomechanics, try to understand their biomechanics. For example, very quickly in 30 seconds, let us look at the mainly between the biomechanics of the knee joint, which the thigh bone and shin bone participate, and then it is basically a joint between the proximal or the distal or the nearer part, which is femur, and the distal component, which is the other, or tibia. So a simplified sketch may look something like this, which will show the bones which are participating, as well as the patelia, which is also part of bone, and then the various ligaments and muscles that are participating to make the action. So if we look at it, this bones and the joint can have translatory motions as well as rotary motion, but certain amount of motions are considered to be the minor motion, like the translatory motion. You actually voluntarily don't perform this motion, so they are not very important from the point of view of sports engineering. So although there are 3 rotation and 3 translational motion which is possible in this joint, the translational motions are considered to be minor motion. Of course, when you jump from a height on the hard surface or a ground, the bones will move with respect to each other in a linear fashion also, but then that's not what you can control. And so these are generally neglected. So in sports engineering, we consider them as a 3 degree of freedom joint, okay, as orthokinematic joint. Okay, so this the flexion extension part of this joint and the translation part, these are very much documented. If you pick up some good book in biomechanics of, you will get all these dimensions, and you can basically look at them. Certain things will be considered as important in sports engineering, certain things may not be considered. So for example, you can pull your finger with the other hand, and then you see that it extends by a couple of millimeters, but then you voluntarily cannot do that, right? You cannot, when you are running a 100-meter race, it is not that when you try to touch the finish line, you can extend your finger by this 2 millimeters and then touch it. That's not possible. So they are not important for sports engineering. They may be very important for rehabilitation, they may be very important for medical field, but they are not important for sports engineering. That's why you do not separately study them. We also need to understand there are very many body disposition, natural disposition. They are not deformities. For example, a William Herbert's chart of 3 main body types, or rather somatotypes, which are ectomorphic, mesomorphic, endomorphic, are very, very important, in which there are also disposition in terms of racial state. For example, Caucasian, Negroid, and Pacific races are there, which are major races. There are sub-races in which also the body ratios play a different picture. So if you want to analyze the body, it is like machines of similar kind, but made by different companies. So that's how you can look at it when you try to analyze them. So the ratios of the length of the bones and the muscles will be different, and their touching point may be different. There is also a varus and valgus disposition of human being in terms of male-female disposition, in terms of varus valgus within male, within female also. So these also plays some picture in analyzing the biomechanics of the human body when you are trying to work with the human body, and we need to be conscious about it. We can very easily form, if you can use a software, mechanical engineers can build this kind of a muscular model of the leg, where major muscles are simplified. Of course, if you look at gluteus maximus, it's a very, very complex muscle, wide muscle, covers the major part of your hip, but then here it is simplified in terms of the joining points where it joins with the bones and for the actuation. And then you can also build a, let us say, a kind of a 7-segment kinematic model. There are ready-made software for analyzing things. You can also take this up as a project and build such a model and give some motion to one of them and look at what are the forces generated in other muscles in which are attaching these bones and so on. So that can be a very beautiful exercise, because some of the softwares which does it are very, very costly. Okay, so we do have this kind of system, multi-camera system, to analyze the human body, because when you have done a analysis or when you have done a modeling, what you get, that has to be established, okay, that your model is perfect or near perfect. So which can be done, that these are of course very costly propositions. We can have markers. Nowadays, of course, markerless motion tracking is also possible. And this kind of markers can be put on the body, and then the athlete can be asked to be performed. Generally, these are all performed indoor. Outdoor performance tracking has other challenges which are to be avoided. And then these can be picturized and then taken as a task of analysis of the pictures or the photographs or the video analysis, and then you can establish your model, what you have done. Here, I'll show you a small example, which is basically not done with a elaborate system, but we took some picture with a mobile phone and in a live performance, and then we use some relatively cheap software to understand how the body angles are there. For example, if we run this one, so this is a athletic activity in which we mark this limbs in terms of 2 lines, and then it tracks in the whole of the picture how these 2 movements were there, and then it plots this angle, change in the angle with time frame. And then we can take such motions from capture such things from a trainee athlete, and then try to compare it with a trained or elite athlete, and then try to gain some benefit where one has made a mistake. In this particular case, the athlete has made a mistake and could not maintain her balance and then has fallen down. Okay, so for budding engineers and teachers, it is also important, of course, to work and then publish their work. So here are some things I have put up where there are a lot of journals which are eager to publish and then accept your work in the sports engineering domain. All kinds of work. These are, some of them are Scopus Index, some of them are SCI Index, and then these are very, very popular journals. There are major research groups all around the world. Of course, they will only accept you once you have shown some certain amount of capabilities. You can also look at certain resources which are available online. For example, tennis measures, the link is given. It's of course a commercial link. And then you can learn about them and then utilize. The whole exercise of my presentation is basically aimed at that some of you budding engineers, very talented ones, will possibly get enthusiastic about this work and then try to focus on sports engineering as such, as a part of your career or maybe as a hobby, and then things can build up from there and then everybody can benefit. As such, in India, as we have discussed, it is a new field, relatively new field, and then not many are working. So if you come early to this field, you have an obvious advantage. You can shoot questions if you have, you can type it out, questions, or you can connect with Dr. Vishwanath, who can send me the questions and I can try to answer some of them. You can also write to me, feel free to write to me. Thank you. I must have overshot the time, but then I really enjoyed my presentation to all of you. Thank you.
Thank you so much, sir, for the valuable information. And it's even more beautiful to link technology and when it is something studying about our own body and resulting in a better performance. We do have a question from the chat box here from Varun. So the question is if there is any note on the performance fabrics by the athletes.
You are Yeah, scope of, so I mean, I guess that question is about fabric. Yes, we are not immediately working on fabric, but then there are ergonomic aspects in terms of fabric, which are, I mean, sweat resistant, or when you are sweating, it do absorb and then allow air movement and so on. These are very important. Sushma mentioned in the chat box, you mentioned sports engineering evolving. Yeah, sports engineering evolving definitely, and then particularly in relation to India, there are scopes of job, not as many as you can, of course, look at a software engineers or something like that. The job opportunities are that way limited, but then every important clubs and every important sports body are getting conscious about need of sports engineering, and very soon we may look at more job opportunities. Of course, you have to be a good engineer first, and then work on your knowledge, apply your knowledge in sports engineering. That's the skill of it. However, in Europe, many countries, in US, in Canada, in Australia, and a couple of other countries, there are degree programs, full-fledged engineering degree programs in sports engineering. There are master degree programs as well as PhD programs in sports engineering. Mr. Manas has a question. Are ball impact tests carried out while manufacturing? Ball impact test is supposed to be carried out while manufacturing. Yes, I mean, certain kind of, I mean, at least some sample, it has to be carried out. Yes, that should be done. Without that, balls will not be accepted for a certain level of play. Yeah, there may be more queries. Let us wait. I mean, you can always connect with Dr. Viswanathan. You can reach out to me and we can try to answer. Thank you.
Thank you, sir. I think due to the time constraints, the rest of the questions will be mailed to you if there is any of such. And
my
again,
pleasure.
like to thank you for giving in your time to share your valuable knowledge and information with all of us. Thank you, sir.
Thank you.
Moving ahead with the next speaker. Moving ahead, I would request Meenakshi ma'am to give the introduction of our next speaker.
Good morning, everyone, respected dignitaries and fellow participants. I deem it my esteemed privilege to introduce our speaker for today's program. Professor Venkatesh, Assistant Professor, Department of Mechanical Engineering, BITS Pilani, India. PhD Nano Biotechnology from IISc, Bengaluru. MS Micro Electromechanical Systems from Coventry University, UK. Bachelor's degree in Mechanical Engineering from VTU, Belgavi. Research interest in MEMS, NEMS, vibrations, finite element methods, neuroscience, oncology, myography, biomechanics, medical diagnosis. Professional membership, Institute of Electrical and Electronics Engineers, Life member, Institute of Smart Structures and Systems, Indian Academy of Neurology, Society of Experimental Mechanics, Life member, Sports Engineering Association, patent filed in method and system of inductive muscular disorders. He worked associate research, associate lecturer, visiting faculty, professor, associate professor. He published more than 15 papers in referred journal publications, conference proceedings, and workshops. Awards, Travel Awards, SPIE Phonetic, West San Francisco, California. Extension of module parameters and micro machine resources in higher modules. It is indeed our great honor and privilege to have with us such a distinguished personality sharing his knowledge with us today. Thank you so much, sir, for being with us.
I would request to take over the gathering.
Yeah, thank you, Dr. Meenakshi, for the kind introduction.
Thank you, sir.
Hope my screen is visible to all of you.
Yes, sir.
Okay, let me thank Dr. Vishwanathan and Sports Engineering Association and RV College of Engineering for inviting me to present the work on the smart sensors and how we are going to use the smart sensor technology in sports. Okay. First, if you look at the smart sensor, right? Here, we all of us at present till now, Professor Datta has explained you about the uh, biomechanics of sports and other stuff, and Anil has explained you about how we are using the sports surfaces, and also during the Anil's lecture, you have heard about the synthetic surfaces, and also during his lecture, he mentioned about how the sensors can be used in the synthetic surfaces. Now let us see how we can use the sensors in the sports. Okay, now if you take up a smart sensor, any smart sensor under consideration, now you take up any sports, right? Say that football, right? During football, you are going to basically you are going to what? With your foot, you are basically pushing the ball, right? And if you run also during the running process as well, our foot will also face the pressure, right? So we would like to even monitor how much is the foot pressure levels under consideration. And also, if you take up the some of the majority of the cases, wherein you have even seen that you have noticed that the majority of the sportsmen are dying because of the cardiac arrest and other stuff, right? So it would be quite very easy if we can measure the cardiac activity in the live, right? So that if at all there is any cardiac arrest would have happened in another hour or two, then it will come to our notice well in advance, right? So it will be very easy for us, so that it's always easy, so that we get if we can develop a smart sensor which can measure the real-time activity of the real-time ECG, real-time EMG, and other stuff. So that will be very handy for us, right? So that's what it is, and that's what I was mentioning here. If we can monitor the EMG is for electromyography, and then one can even in case of electromyography, whatever you can see over here, we have plenty of surface mounted electrodes which are being mounted on our body, right? And we can even transfer the signals wirelessly, and we can even monitor on our mobile itself. And nowadays we can the people are coming up with a smart waves, right? Or the smart textiles. What we do is that we basically within our textile itself, we are going to embed the sensors into it. Once I embed the sensors into the textiles, then we can see that then during the real time, I can monitor all the physical activity. I can monitor the motion, I can monitor the pressure levels, I can monitor the cardiac levels, everything can be monitored in the real time, right? So if you take up a sportsman, right, during any sportsman consideration, if he is doing the weightlifting, then I need to monitor the muscular activity, and I need to monitor how much is the load carrying capacity also. And also, let us say that if he is a runner and he is a weightlifter under consideration, I need to monitor his heartbeat as well, right? Who knows at what point of time he will get the cardiac arrest, right? So we need to monitor the cardiac activity as well as the muscular activity. So that's what I have mentioned over here. So one need to look into the cardiac activity, one need to look into the muscular activity as well. And let's say if you are a runner under consideration, you need to look into the real-time monitoring. Let's say you need to look into the positioning of the individual, right? And also nowadays you might have seen, right? The earlier old watches, the Titan watches and other stuff, it used to show us only the time. But nowadays you are getting a smart watch, right? And your son or daughter will call you just with your watch. Papa, come over here. I am here. I am facing so and so trouble, right? So nowadays the technology has evolved so much. So even with a click of a button, you can see this is a smart watch. It can do plenty of so many things. It has plenty of sensors built into it. It has an accelerometer, it has a heart rate sensor, it has a biometric sensor, it has a gyroscope, and it can even measure the SpO2 levels, and it has a vibrator, it has a GPS system. So, and it is even as a respiration sensor, right? Let us say somebody will, let's say somebody is having the COVID, right? And by chance, his SpO2 levels go down, just you put up this smart way with us, that will measure everything in real time, right? So these smart sensor technology is a very plays a very important role or a vital role in many of the sports under consideration. Right now, if you look at the technology evolution, so what can you say here? What can you see here? If you look into this, right, these I can basically have is this, right? These are all basically the one is the textile industry, very old textile industry was this, and automobiles, they used to be so large, and the energy, they used to consume the whole village, right? And earlier biomedical devices, they are all so huge, right? But today, how was it? So they are all, everything is miniaturized, right? And what would happen tomorrow? Tomorrow, the entire automobile industry, it would come like an Apple car, and whatever you are getting with a prick of a blood, tomorrow you will be having on your mobile phone, right? On your mobile phone itself, just place your mobile phone on your hand, you will be getting the A to Z information about your body. So how do we get it? From here to there, from the yesterday to tomorrow, what is it? So if you look at between the previous generation and the today's generation and tomorrow's generation, right? So what basically is that it should be accurate enough, and it should be cost effective, and it should be what? Time, right? Time is what? That should not consume more time. Earlier time, in case of a biomedical testing and other stuff, right? You might be aware that whenever they used to go for the sugar test earlier, they used to take up 3 days, 4 days to give one report. Now, within a second, you are having a results with you, right? So that's where it's within a very short duration of time, you are getting quite a lot of data with us, right? So that's why it has to be accurate, it has to be cost effective, and it should be very quick. That's what is this? That is accuracy, cost, and time. So that's why this is what I am written it as ACT, right? So how can we achieve this? How can we achieve this? So let us see how to achieve this. So ACT in the today's R&D, right, is accuracy, cost, and time, right? So how to achieve this? First is accuracy, that is accurate, it should be precise, and the detection requirement, it could be a dengue detection and monitoring the adulteration of the milk. In that case, if you take up the sportsman under consideration, I want to measure in a real time what is the position of the sportsman, what is the what is the heart rate of the sportsman, and then I want to measure what is the force on the foot pressure for the sportsman, everything I want to monitor, all of them will come under this, right? And if you look at the affordability, let's say that if tomorrow I want to, let's say I'm going to put X money for this, it has to give a value for the money, right? It has to be affordable pricing, right? So value for money is also very much important. And for example, it could be an electronic gadget, or it could be a biomedical device, or and then the other one, what I said is time. First one is accuracy, second one is the cost, and third one is the time. It should be ultra fast, right? Nobody wants to delay the process by so you take the project today and you take up another 10 years. Nobody wants it, right? So it has to be ultra fast. All right. So, for example, it could be a solar project or any electronic gadget, or it could be any biomedical device. In that matter, any of the sports sciences, it could work. So let's say that I want to span across all three of them. How should I go about that? What is the solution for this? The solution for this lies in the micro and nano system, right? So micro and nano system has been proven to be a known source, known source for this, right? Known answer for this. So let us see what is this. I have the macro world, another one is the micro world. So once I go from the macro world to micro world, right? For example, your tennis ball, that's what we have for your sports, right? And once I go from macro world to micro world, and as you know that the majority of your human cells will be typically in tens of micrometers. And if you go to the proteins and other stuff, they will be in few nanometers, right? So once you go from micro world to nano world, you can see that basically have the several micro scale devices over here. So can you differentiate between what is there over here and what is there on the other end? Can we differentiate between the two? Right? If you look into this carefully, all of this, they are all the natural system, right? And then these are all our RBCs, and this is our ATP motor. These are all the natural system. On the other hand, what you can see over here, these are all right? On the other hand, if you see from the other side, these are all the man-made devices, right? These are all the micro machine devices which are basically done in the using the fabrication techniques. Now, as I mentioned, the micro and nano system is the one which gives the solution for any biomedical industry or the sports industry under consideration. Now, let us see what exactly is the miniaturization. For any miniaturization, this basically comes from microsystem technology, whose dimension would range all the way from 1 micrometer to 1 millimeter, which is basically called the top-down approach, which is initiated in 1947. That's where we got the independence. And also this microsystem technology also started by the invention of transistors in 1947. But the term micro machining and micro fabrication that coined on 1982. On the other hand, there is something called the bottom-up approach. That's what we call it as a nanotechnology or the nano systems. Typically, any of the nanotechnology under consideration, it will be typical dimensions would range all the way from 0.1 nanometers to 0.1 micrometers, and it goes back to what Richard Feynman said. There is plenty of room at the bottom in 1950s, right? And he was a professor at Caltech. He gave a wonderful talk on plenty of room at the bottom. Whomsoever is interested to work in the field of micro and nano system, they have to go through that article, right? It's a wonderful article. You will you yourself will feel, right? That basically will lead us to the two fields, micro and nano systems. Now, I will, for the time being, I'll just keep the benefits of the micro scale and other stuff. You can read it, right? It's a better surface to volume ratio, and it's a cost effective, and also since it is small in size, and overall power consumption from the micro scale will be extremely small. And as we are doing it from the batch fabrication, the overall cost per product will come down very drastically. Now you can see this, your macro world in comparison to your micro world. Everything in your micro world will come under your palm. Right. Now, what does MEMS basically stands for? MEMS basically stands for micro. Those are micro fabricated devices. And electro, basically electrical input or the electrical output. And this will be having the mechanical functionality associated with it. So it's a mechanical term will come. And since everything we are going to have it as a devices, or the devices or structures or systems, it can be even used to control the stuff. That's where this term MEMS came into picture, which basically stands for micro electromechanical systems. So it could be electrical input, mechanical output, mechanical input, electrical output. Depending upon that, we can classify them into either a sensor or an actuator. Now, MEMS in a nutshell, as I mentioned, the MEMS can be either a sensor or an actuator, depending upon the energy transfer from one domain to the another domain. If at all we are going to, as we know that electrical energy is the one which is easy to measure, right? electrical energy is easy to measure. So this is a measurable form of energy. That's what one which converts all the form of energy to a measurable form of energy. That's what we call it as a sensor. And on the other hand, mechanical energy, as the name itself indicate, actuate, right? So actuate means move. Motion is a mechanical form of energy. That's what one which converts all the forms of energy to the mechanical form of energy is basically your actuator. So MEMS in nutshell, you can take it as a sensors and an actuator. These are all some of the measurements we can have it for an mechanical system. These are all some of the measurements we can have it for an electrical system. Now MEMS we can have it for the batch. Anyhow, I already discussed, so I'll skip this slide. And some of the applications for the MEMS, there are plenty of applications for the micro scale devices. For example, in automobile industry, medical industry, defense industry, even many sensor techniques, even that matter, sports as well. These are all some of the micro machine. All of you might have seen your projectors and other stuff, right? Typically, if you take up your projectors, there will be plenty of micro machined DPDs, right? Digital projection displays, right? You'll be having plenty of micrometers. Each micrometer is this, whatever you can see here, right? This small dabba, each one is this. So you will be having plenty of micrometers underneath this. And then this is what you can see in your projection displays. And also whatever the star marks you can see over there. If you would have seen your cars, right? Each car is having plenty of sensors built inside it. And also, if you take up in our sports industry under consideration, right? Let's say usually nowadays we are going for something called e-skin or e-fabrics. Sorry. We are going for e-skin or e-fabrics, wherein we are basically embedding the sensors inside your fabric kit. Right? Once I embed the sensors into your fabrics, then since you are embedding the sensors could be in the like a microphone, or it could be like an accelerometer, it could be like a gyroscopes, or it could be a pressure sensors, even it can be an oximeter, right? So one can even measure what is the audible level, the sound levels, and what is the lung capacity of the individual if we are putting up an accelerometer over there. And also we one with the help of electromechanical devices, we can even monitor what is our in the life, what is the temperature level. So one can even monitor use the help of micro scale devices. Let's say take up an example of the boxing, right? We can olden days, if somebody kicks it and he will even go for coma, right? Now let us say that somebody will kick it and we can even put up an alarm for the other guy, right? We can, if you have the helmet, right? To the helmet, we can embed the sensors and we can even put up an alarm that if he gets a so and so, then immediately the alarm will shoot up and we can directly take him. So we can't injure all the sportsmen for everything. And also similarly, let's say that during our in the earlier days, we used to have the gait analysis, right? All of you might be aware of the gait analysis, right? During the gait analysis, what we do is that we basically have the floor and we will walk on the floor, and beneath the floor, we have all the force sensors, right? But those force sensors, they will basically give us all the and once you walk on it, they will basically give us what is the force levels. Once I walk on top of it, as a function of time, you can measure what is the force, right? And let us say that you are walking somewhere and you want to measure what is your foot pressure at each and every point, right? Then what we can do is that here you can see this is a shoe, right? In the shoe, I can even embed a pressure sensor over here, right? Once I embed a pressure sensor over here, then in real time, I can monitor the foot pressure levels, right? And earlier days, you might have even seen, noticed cheating in several cricket and other stuff, right? So you can even have small crickets, right? Wherein we can have a plenty of sensors embedded inside your ball, inside of your cricket ball. You can see these small sensors which has been embedded over here. These sensors, if we embed inside of the cricket ball, That's what we call it as a smart ball under consideration. Then in the real time, we can actually monitor the position vector of a ball. We can monitor the angular rotations, and let's say it comes in contact with the bat. Then also we can monitor, let's say if it goes and hits the wicket, everything can be monitored in real time, and somebody will catch us. Everything A to Z we can monitor about your cricket if help of the smart devices. Now, whenever we go for the making a micro scale devices, these are all the typical steps, right? So first is our design, next will be your fabrication, and third one will be the testing, and finally it will be the system integration for the next. Now, these are all some of the devices which I myself had fabricated when I was at Indian Institute of Science, and these are all the micro machined cantilever beams. And I mentioned you in the earlier slide about the microphones which can be embedded into the skin, right? These are all the micro machined microphones which can be embedded, which can measure in real time what is the acoustic level under consideration. And these are all capacitive micro machined ultrasound transducers. Even they can also measure the in real time. Let us say that I wanted to embed inside it, and I wanted to measure what is the blood flow rate and other stuff for the blood. Everything I can do it with the help of our acoustic transducers. On the other hand, if you take up the gyroscopes are basically meant for measuring the angular rates. Even let's say that if you are going to twist a ball, right? If you are going to throw a ball, at what angle you are throwing the ball, everything you can monitor with the help of the gyro. And the torsional mirrors and other stuff, so you can have plenty of applications of this MEMS device. And this I have already showed you. Now, all of you are using your smartphones, right? All of you use it, right? Now, if you touch, right? If you touch your smartphone, then immediately it will sense. How does it basically sense? It basically sense by the capacitive beams, right? So if you touch your smartphone, then what is happening is that we have two parallel plates over here. If you touch it, then there is a deflection of this. If there is a deflection, I have two plates. If there is a deflection, then there is a change in the air gap. There is a change in the air gap. This change in air gap will lead to the change in capacitance, right? Since there is a change in capacitance, that change in capacitance in turn will be a measure of how much is the force we are exerting onto it. That's the basic principle behind the majority of the sense devices under consideration. I was mentioning you about the micro machine accelerometer, right? This accelerometer basically consists of a proof mass with the help of set of beams, and we have one fixed set of comb fingers, another movable set of comb fingers, right? And once there is acceleration, then the proof mass will move. Then we can see that there is a capacitance change. That capacitance change in turn is a measure of what is the acceleration coming onto the structure, right? On the other hand, if you take the pressure sensors, the same way we can measure the pressure sensor as well. The pressure sensors can be used in several applications. For example, if you are giving a shake hand, right? Then also you are basically applying some pressure onto the other hand, right? So we can make use of the E-skin, and we can monitor the pressure levels. And also we can even use it for the several healthcare devices. And also let's say that when you are speaking, then also we are going to have the pressure on this part, right? Then also there also you can put up a variable electronics, you can always device, and you can have the. And so typically the pressure sensor works like this, right? You can see this. We have the whenever there is an input pressure, there is a deflection of this. When there is a deflection, then it would further lead to the change in resistance. And this effect is what we call it as a piezoresistive effect. I don't go into details of the math and other stuff. I don't want to get bored with the math. So as the time being, you just understand that whenever there is an input pressure, that would gives us the stresses. Those stresses will in turn lead to change in resistance, and that effect is what we call it as a piezoresistive effect. The change in resistance will be converted into the voltage. And you can even design your pressure sensor in your lab. It's very, very easy to do that. What we need to do is that PDMS is we can even purchase it from the market, right? And CNTs, you can even well fabricate it at RECE itself. And what we need to do is that we need to just mix the mix PDMS with the carbon nanotubes, right? Once you mix PDMS with carbon nanotubes, what happens is that the PDMS becomes a piezoresistive material, right? Since the carbon nanotubes give us some piezoresistive properties, then it becomes a piezoresistive material. And you put up some material beneath this so that you will be basically having a post like this, right? So you'll be having a post like this. Here I have basically put up a polystyrene piece, right? So that you will be having a post whenever there is a pressure, then there will be a deformation of this that will basically gives us the voltage output. We can always tap out the voltage output between the two CNT layers, right? So we can see the similar procedure over there that we can even post. That's what you can see this. It is already put up on the hand. The entire device is just not even a centimeter, right? You can just put it on your hand at real time. You can monitor all the pressure levels, and we can see that if you apply a different pressure levels, there will be different current output from the device. One can use, and you can even work with several devices, right? You can even once you look at developing any e-skin under consideration, one need to look at it from the design perspective. One need to look at it from the design principle. One need to look at what are all the first we need to look at the biocompatibility of this, wherein we can even make use of the CNTs, whatever I have explained you just now. And if you look at it from the sensory perspective, the sensors, it can be of it can be a dynamic pressure or it could be a static pressure, right? And also one can even look at it from the strain detection, and one can even make use of a supercapacitors. And for the signal detection purpose, one can look into the amplitude, one can look into the amplitude ratio, one can look into the frequencies as well. Right. Now we got the signals, we need to signal generation and signal analysis. For signal generation, we can basically make use of the several techniques, for example, single electrode, and then we have the two freestanding one wherein you make use of the capacitive technique to measure it, and you can make use of this. So for the MEMS resonator, I have mentioned you that the MEMS and NEMS basically gives a, how much time do I have? Is my slides are moving properly?
Yes, sir. Yes, sir. It's going on.
Okay. Okay. If you, as I mentioned, that MEMS and NEMS is the one which promises promising technology for the sports, right? So MEMS is basically in that. If you take a MEMS resonator, it's basically made out of this, right? So it will be, if you keep the dynamic response of any MEMS device under consideration, any dynamic system will be like this, right? So you will be having, one is this, basically the response curve would look like this. As a matter of time, I'll skip all the back. So which can be further classified into stiffness dominated, damping dominated, and inertia dominated regime. And if you go from macro scale to micro scale, we can see that the resonant frequencies will scale as L to the power -1. So that means usually the frequencies will shoot up once I go from macro to micro. So one can look at it from the analytical approach, numerical approach, or from the experimental approach. Now, these are all some of the gyros. I have mentioned you that the gyros and accelerometers can be used in reality to monitor the motion, right? So the MEMS gyros basically make use of drive circuit to drive it. And once I drive it in the drive direction, then if there is, the person will move, then there is a rotation of the person. Then it is you will be having the capacitance change in the sense direction that is measured using the sense circuit, right? So that's what we can see. If there is a close match between the drive and sense mode frequencies, we have the huge sensitivity, right? These are all some of the devices what we have done, right? This is how the typical gyroscope structure looks like. This is called a tuning fork gyroscope. We have two modes of vibration in case of a gyroscope. One is a drive mode, other one is a sense mode. wherein during the driving, they are basically done using the anti-parallel motion so that your linear component will get cancelled out. When there is a rotation, we get the Coriolis force. That's what is basically picked up in the sense direction. And this is a 3-axis gyroscope which we had designed, right? Wherein this is the first, we are the first in the India to design the 3-axis gyroscope, right? And of course, nobody has fabricated till now in the world as well. And we are going to fabricate it during my project. We have wherein we have the drive in one direction, and we have 3 sensing the real-time sensing, right? So we are going to drive it along this direction, and when there is a pitch, roll, and yaw, we are going to we get different modes of vibration which are basically sensed with the help of this sense capacitors, whatever has been patterned over here. Now, similarly, we can make use of what is even called the hemispherical resonator gyroscopes, which basically looks like this hemisphere over here, which is attached to the stem, and this is how the modes would looks like, right? Where the one mode is this drive mode, which we are basically driving it with the help of these drive electrodes, D1, D2, D3, D4, and once there is an angular rate signal, then it will immediately change the rotation angle, which is sensed with the help of this sense electrodes S1, S2, S3, and S4. Right, and this is the HRG what is fabricated over here, and we had measured with the help of my system or whatever we had developed here, right? So we can, as I mentioned, the HRG is basically one can make use of the capacitive sensing or the piezoelectric sensing. Here what we did was, here we even put up a piezoelectrode at the other end so that whenever it undergoes rotation, there will be a strain. So that strain will be further gets converted into the electrical output from the piezoelectric system, right? So that's what we are basically looking at in the spectrum analyzer. So once I look at it from the optical technique, whatever we have and the piezoelectric system, we can see that the optical and the piezoelectric are giving us almost the same, right? So, and if you look at, if you want to look at the things in real time, you know that the nature has already a well-established sensors with it, right? For example, the RTS of the insect are having a wonderful RTS or the wonderful gyroscopes are in nature, right? What this RTS basically have is this simple cantilever-like structures, and at the base of the RTS, we have something called this sensillas. These sensillas are called the campaniform sensilla. These campaniform sensilla are like a strain gauges. At the base of this, we have the strain gauges, which basically will measure the strain. For example, you basically undergo, you will rotate your hand, you will feel some strain at the base, right? At the joint, you will feel the strain. So those strains are basically measured using this sensilla. And in our case, we are basically getting our strains, we are basically measuring with the help of our muscles. But over here, instead of the muscle, we have this sensilla in the insects, right? So we can even design the system with the help of this, and we can take the inspiration from the nature, and we can even design the systems as well, right? So that is what the entire technique is called, the biomimetics. So what we did was we had taken the insects, the Drosophila is equivalent to the, in the genetics terminologies, the Drosophila is a somewhat is equivalent to the human system. And we, as I mentioned earlier, that RTA is already an existing gyroscope within the insect. So we took the RTA over here, these two things, whatever you can see, right? These two are the RTAs, and we measured in real time, and this is what we got, and these are the, right? Now, yeah, that's what the entire system, what we call it as the sensory systems, right? So what is the existing systems is that the micro and nano world, we always design the structures, but nature has already well established sensors with it. And even within our human body, there are plenty of sensors which are there, right? Let's say that you pick your hand, you can immediately feel your pain, right? That basically what is happening is that once I tweak it, what is happening? There is a strain over here, right? That strain gets transformed into the electrical output. That's what is basically beneath our skin. We have the ion channels which are there, right? Whenever you are going to open, whenever you are going to tweak it, these mechanical receptors, right? There is something called stretch activated ion channels. The stretch activated ion channels will open up, then the ion starts to flow through it. Once the ion starts to flow through it, then there is some electrical output, right? So this electrical output in turn will be a measure of what is the mechanical input. So similarly, we have the gyros in our ear as well, right? For example, if somebody will be having some problems with the ear, then he will feel the entire world is rotating within him, and he will immediately run to a ENT. So what is basically happens is that within our human ear, we have 3 fluid-filled cavities. Those 3 fluid-filled cavities are maintaining the stability of the entire body. Right? Otherwise, your entire head will start to rotate. Right? These 3 fluid-filled cavities are maintaining the stability of our entire head. Right? So this is an entire new area is what is called the biomimetics. Right? So let me acknowledge both of my PhD students who are working on it, the Deeplesh and Pradanya, and this was a project funded by the Indian Navy and the Naval Research Board of the DRDO. And thank you everyone. If you have any questions, I am open for it.
Thank you so much, sir. It was a very informative site on understanding the applications of biomechanics and the sensors and how it works. If there are any questions, I think they'll type it out in the chat box.
Yes, one attending has raised the voice, has raised the hand. Yes, any questions? Please do type out in the Q&A.
I guess there's no questions. Thank you so much, sir. Thank you so much for the valuable information and for your time. And we will be giving the certificate for you to give us some knowledge on this. So thank you so much for participating. And moving on, I would request Dr. Vikram sir to give the introduction of our next speaker.
Vikram sir, is it audible? Vikram sir.
Due to some network issues, we will be talking about our very own Mr. Rajas Javalkar, who is a shuttler who has fondled a love for the game right from his early days, who is also RV alumni. Born and brought up in Karnataka, he's an alumnus of RV College of Engineering. He also holds a master degree in sports management from La Trobe University in Melbourne, Australia. His achievements in the world of badminton are commendable, and the main ones are included here. So he won a gold medal in the 53rd National School Games of India. He was awarded Sportsman of the Year for the year 2007 and 2008 and was facilitated by the Chief Minister of Karnataka. He won the singles title for a grand total of 15 times at the state level. In his 4 years of RVCE, he has won the VTU South Zone and the Interzone with the team consecutively for 4 years from 2013 to 2016 respectively. He also represented VTU in the South Zone Inter-University Badminton Tournament. During his masters at La Trobe University, he represented them in the National University Games at Gold Coast, Australia. In the world of sports persons, Mr. Rajas is surely in the elite category, and we are delighted at the prospect of having you, sir. I would request you to address the gathering further. Thank you.
Yeah. Hello. So
Yes, sir. It's audible.
okay, yeah. So I just need to get the presentation up. Just looking how do I get that?
Rakshita, if you have put the PPT of the speaker's biodata, you have to come out of that so that he can put his PPT.
Yeah, I'm not able to like share my screen. Can't see the option.
Sorry, sir. Actually, we have made him as the presenter, so he will be able to present the presentation. Like
No,
how the
but
other
you have
speakers.
put your PPT here, no?
Yes, sir.
That has to be off.
Okay, sir.
Yeah. Yeah. So can everyone see the screen?
Yeah, it is
Yes, it's visible
seen now. Yes.
and audible.
Okay. All good. So my name is Rajesh and it's evening time here. So I'm in Australia right now. So today my topic is gonna be on sport management. So I have done my master's in sport management, and as per the introduction, like I've been an alumni of RV College and studied industrial engineering and management at RV IEM. So first of all, like I'd like to thank RVC and the sports department for like giving me this opportunity to share my insights into the world of sports, like sports management. So just wanted to highlight before we start that this is like the table of contents what I'll be talking to, but not limited to only this thing. So like during the presentation, I'll also be sharing a few insights about the playing career and also about what I learned during my master's in sport management. So it'll be like a good blend of both practical and theoretical knowledge. So yeah, so as I said, like with the opportunity that I've got, so the first rule of sports and sports management is to take the opportunity, like the rule 101. It's always like to grab the opportunities that come your way. So it's like no matter how small or big the opportunities might be. So yeah, so let's start. Yeah, so so sport management, like, so what is it like different about sport management that people talk about? So it's like, it's not, I would say that it's not relatively a new term that is used. So it's just a term that is used by sporting organizations a lot. So like we do have different types of managements, like project management, you have human resource management, and sports management also does fit in that umbrella of management. So just going by the definition, the book definition says that sports management as a process is of organizing and managing the sport or sporting organizations for the purpose of gaining the sport and other results with the rational use of limited resources. So the thing with the limited resources is because you are subjected to time frames and goals within the sports management because it's a highly evolving and a dynamic environment that we work in. So it's like you have to be able to like be quick on your feet and make decisions and like devote a lot of time to it because it's very unpredictable and dynamic. So I'll be basically talking about sports organizations a lot in this presentation. So how organizations are different from other management organizations. The goal of sports management is organizing and achieving top sports results and therefore useful of the economic investment. So It basically states that, as we all know, sports is like $1 billion industry as of now. So it's just that there's a lot of investment coming through in sports. Like I wouldn't particularly point out any sport as such, but there are like a lot of sports which are gaining a lot of investment and popularity. So I would say like in India, I would say badminton has grown a lot in the last like 5 years maybe. So when the likes of Saina and Sindhu have just taken it to the next level. So because I remember during my like playing days, like me and Sindhu were everyone were of the same age, and then there wasn't much like scope and popularity going through. But now it's like taken to a whole different level. And then just to talk about general sport can wear like different hats. So one can be work, like you can be a professional athlete, like representing your team or a country at the international level. And the next can be your bread and butter, the employment. Like you could be a sports tourism director, or like work at a sports marketing agency or something. And then it can be a business where you're working for a sports organization. So this is like a general overview of what sports and sports management basically is. So next I would talk about particularly India and how sports management has evolved. So this is like from a 2020 thing that I found. So it does say that sports sector is dynamic and globally dominating industry. Sorry, and then with the emergence of Indian sports, a key player in global markets, the scope of sports management is rising definitely, significantly. India has also witnessed a lot of multiple startups in sports going over the past of years. So these include like infrastructure, data, content aggregation, education and training, online retail technology, and online ticket booking. So just to like give a quick example regarding this, like when during my playing days, and I would particularly relate a lot to badminton because that's the one sport that I've played for the last like 15, 16 years maybe. So like I would say like last 10 years when I started playing, so there wasn't much like a technical aspect to the game. So it was all like you just learn from others through word of mouth, and you didn't have like a lot of technicality going in the game. Like there's not much like technology involvement happening. But because of data and because of like a lot of data and the technology going, you have so many different like you can literally watch anyone playing anywhere around the world right now, and then so you can like analyze their games, and then you do have softwares now as well where you can code the games. So that's like changing a lot these days. So just moving on how the sport organization works. So it's no different to any other management organization. So I would say like these are like the 7 pillars of sports organization, or what the like the foundation of the sports organization. The first is the organizing. So in the organizing, you would have like the main managers organizing like the goals, the mission, vision of the organization as to what they are planning to do and what would be the future goals of the organization. The next you would have like decision making. So this is like the most important thing, because if your mission and vision is like a proper goal oriented and you know where you want to be in the next 5-10 years as a sports organization, so the decision making has to be like very strategic. So then comes the control. So the control is like, so basically it just talks about the financial aspects of an organization as well, because you are limited to resources. As I say this because not every organization in the world would have like sufficient resources to like fund their players or like support their players. So the control is one of the, like I'll say, like the main engine of the sporting organizations. So next is communication. So communication is like the very most important thing in any organization, and particularly for sports organization, communication is important because because like you have to communicate with your stakeholders, and then you have to like involve the public as well. So stakeholder communication is like one of the important roles of a sports management house. So what happens is like, so like for example, like if you're running an organization, so you'll have to get the local community involved in it. So you have to like understand what the local community does. Like if you have a playground, so you need the equipment and everything. So the next thing is planning. So the most important thing is in planning would be the projections as to where do you see yourself and how are you planning your next step, because you would have a lot of competitors as well. So the next is innovations. So I'll even touch on innovations in the next slides, and I'll just talk about one innovation which has changed a lot. I'll talk that in the future slides. But for now, innovation is something which is evolving a lot. So like every organization is trying to innovate at something or the other, because if you are not innovating in this era, so there's no progress in particular like a sport management organization. So innovation is like the most important thing. So the next is motivating. The motivating comes down to basically it's more towards managers and athletes, because if the athlete is not motivated to perform, there's no point of he or she playing the game or something. So motivating is an important factor in a sport management organization. So moving on, I'll just talk about the different sectors that involved in a sport management. You have the public, the non-profit, and the professional sport. So just to add more into it, so the public sector would involve the national, state, and the provincial, the governments, and the specialist agents that develop the sport policy. So then you have like, for example, like you have all the main sporting national agencies like Badminton Association of India, and then you have like the BCCI. Like these are the main organizations which control the sport in the country. So the main job of the organizations is to promote the sport and to get the state organization involved, and to like basically create a supply chain where the national organization is the head, and then they pass on the information to the state, and the state passes on to the district. So the involvement of all this plays a very important role. And then you have the non-profit or the voluntary sector. So I think this is one of the most important aspects in a sport management, where you have a lot of volunteers who want to get involved in some of the other way in the sport. So like I was no different to it, because when I remember when I came here to Australia, and then the Australia had like this big events like the Australian Open or like the Formula One. So like everyone wanted to be involved in some or the other way with those events, because you get to learn so much as to how the events are happening. So it's not only like related to the aspect of playing, it's also related to the aspect of management, like how do you organize these tournaments, how do you run, and how do you manage the crowd. There's a lot of things that happen that go through it. So volunteering is something which is like captured a lot of I would say, over the years. And the next is like professional or commercial sporting organizations. So like these are basically like sporting apparel, so manufacturers, like you have like Nike, Adidas growing through. So like you have these big companies who sponsor players who achieve like greater heights. So once they come through, you have like marketing going through, and then you get a lot of funds into the sport as well. So like I classify like all this into like different sectors of the organizations in a sporting world. So just to move on, so this is like particularly a lot of like doubts that people have about, so what is like different about a sport management, like a sport organization thing, with respect to the general management or the general organization we talk about. So what I've done is I've just like classified that into 4 different aspects. So I'll just explain one by one about leadership, strategic management, organization, structure, and culture. So we'll just start with leadership. So I've written like single most important thing that a sports manager and a sporting organization strive on. So it's because sports organizations are always on the lookout for leaders who can take the initiative and work throughout and like achieve the results in a professional and effective way. So this is like the single most important thing, leadership. So it's not like you have to be a good leader in terms of like you have to speak well and do well. So it's about understanding what you need to do and doing the job efficiently as well. So this would also involve like collaborating effectively with other organizations and to run a professional league. So it's like, for example, like I have seen here at the Australian Open, it's not only like Tennis Australia who organizes the Australian Open. Okay, like Tennis Australia is the main head of all the organization, but then you have all the small organizations which play a very effective part in like collaborating and running a professional tournament. So it's also like working with different governing bodies as well, because you have like the main governments working, you have like the state government, you have the national government, and you even get sponsors and funding from them. So it's important to like take that onus and the leadership as an individual and as a company, like to communicate and collaboratively work with them. So leadership is one of the most important things. Just moving on. Yeah. So strategic management. So there's like basic like strategic management, how it works. So it can be classified into 3 steps. So the formulation would understand and like, or just talk about all the strategic management and how it fits into a sports organization. So strategic management basically, like strategic formulation basically talks about the purpose, vision, mission, and goals of a sporting organization. So why are the, so like anyone would ask why is like the mission, vision, goals are important. So like the mission, vision, purpose, and goals like set the basic foundation of an organization. Like for example, there's a new organization, and if you want to like strive and be there in the long run, so you need to have a strong mission, vision, purpose, and goals. So if you're like not built on these values, then there's no progress in the future years or months, I would say. So the next is implementation. So once you have your mission, vision, and everything like outlined, then you have to start looking at budgeting as to like what is the budget you can work with, what is the what is the budget you're getting from the government, what is the level of sponsors you're targeting. So it's like, and then it also depends on the athletes, like how are the coaches that are training the athletes, like are the athletes competing at the state, national level, or like are they represented in the country at the international level? So like so it again depends on how much budgeting that the organization has. So then many strategies require organization structure and culture changes in order to create a strategy supportive culture. With no strategy will ultimately succeed. Okay, with that no strategy ultimately succeed. Then is the strategy evaluation. So like it's okay, like you're doing everything, you're doing the formulation and the implementation, but if you're not looking back and rectifying, if you're doing anything wrong, there's no point going forward. So it's all about evaluation as well, like just taking a step back and evaluating if you're on the right track and implementing and financial projections. So just like recently, if you have heard about Lionel Messi, who just left Barcelona, and then Barcelona just came out with a statement that no one is above the club. So because they couldn't resist the Messi in the financial fair play, so because of those FP rules, they had to they said that Barcelona as a club, as an organization is above all the players. So it's about just taking a step back and doing what is best for the organization and not like base your goals based on an individual. So this is like the most important thing. Then moving on. We have the organization structure. So one unique thing about this involvement is voluntary and paid staff. So as I touched on voluntary staff, which is so important in a sporting landscape because you want to get involved. Sports is exciting. You have people coming in from different walks of life, different part of the globe. So you want to be involved in that environment. And then finding the right structure in a sporting organization would include innovation and creativity. So just to elaborate on innovation, this one, the day-night test was first launched in 2015. I think New Zealand and Australia played the first test match here at the Adelaide Oval. So in a survey that Cricket Australia did conduct after that, it did show that 85% of the crowd were in favor of this day-night test match moving forward with the pink ball. So it's about like just twisting and like implementing with innovation and creativity. So okay, like you had your test cricket and one day and T20. So now that T10 is also coming through. So innovation is so important. Like every sport would want to innovate a little bit here and there just to like make it more exciting. Ultimately like moving forward, sports it's all about it's people, like it's stakeholders. Like if you don't have crowds at sports, just like it's so weird watching games. Like we've all seen this throughout the last year when there were no crowds at stadiums, and then you were just like watching players, and it just didn't make sense anymore. So it's just like so the more innovation and more inclusiveness that you have in a sport, so like you have people coming in. So the next thing with the right structure is your communication with stakeholders. Like how do you have that inclusive strategy of involving the public, the local government, the local community into the sport? The next is decision making and collaboration. It's about like how do you respond to challenges with the state government, the national government, because there will be challenges at every step of life. Like it can be as an athlete as well, because you will be at some point there'll be some injuries or something, and then you would have to like take a step back and evaluate as to what's happening. And the same goes with the organization as well. Like you have to be flexible in with the right decision making. Just moving on to the last part is the organizational culture. So it's related to performance, employee commitment, and inclusiveness and efficiency. So this was this was an article which I recently came through. So this was inclusive framework which is done by Australia Rugby League, which runs the National Rugby League here, the NRL. So what they did was they created the 7 pillars of inclusion framework. So I think they were like the first organization here to just come out with this 7 pillars of inclusion framework, which included opportunities, policy, communication, choice, access, attitude, and partnership. So then what did the Australia Rugby League do? So what has Australia Rugby done? So what they did was they created volunteering, like they promoted volunteering a lot because they wanted people to come and watch the games and to get themselves involved, because like in India as well, you have like sports is dominated by like say cricket a lot, and then other sports are just going through, like just coming up now. So what Rugby League did here was it just tried to promote volunteering so that you have people just come and watch the games for free and you don't have to pay anything, and you can even work at those games, and then you get like a letter of recognition or something. And then so the playing would be, and the playing aspect of thing, what they did was just promoted participants to actively participate. So what they did was they just participate from all groups. So what they did was they just had coaching camps for free of charge so that all students to come and participate and like get included in the game and to promote the game. So what happened was there was substantial increase of 32% in female participation rate from 2017. So there was a lot of female participation which came through because of this volunteering and the inclusiveness strategy with Rugby Australia did, like Australia Rugby League. So this is one example which I came through for inclusiveness. So just to move on, so just a bit of like an overview as to what it is and what I would like say that you take away from it. So like, so don't ignore sports, like because okay, you do have your academics going through, like if you're studying engineering, you do have your academics, and then you do have like you have to attend college every day and everything. So that's there. But then just keep in touch with sports, so that just try to exercise like even half an hour, 1 hour throughout the day, and just go out, play some sport during weekends. It doesn't have to be like you can play like a full 3-4 hours, even if you have to play like 1 hour a day. So it would just like keep you energized and keep you motivated. And single most important thing is like you have to be motivated. And that comes to the second point where it says a good support system is needed. It's the key to excel, so that you have your parents, coaches, you have your professors who support you. So this is like to all the students. It's just that you have a good support system, and it's very important to like understand that sports is an important part of life. So you have to like, it's not like you have to, it's just that it will be very important. Like it will be important to yourself, because if you just play a sport and enjoy it and gain some interest, it's just that sport is an important part of life. So I think that's it from my side for today. So just a key takeaway message that sports is important. Just play any sport that you like, and just at least play once every weekend, at least for an hour, so that you get in touch with sports, and then you're just like being healthy and fit in the long run. Yeah, all good. Thank you. So does anyone have anything to ask, questions or something?
Thank you so much, sir. Thank you so much for enlightening us with the importance of having sports in our life, and also on setting up the example on how we have to balance sports as well as education. If there are any questions, I don't think there is any questions. So thank you so much for giving the overall view about the sports management. We are very glad to have you here. Moving ahead with our next speaker, I would request Rakesh sir to do the introduction of our next speaker.
Good afternoon, everybody. It's my privilege to brief about our next speaker, Dr. K.N. Subramania sir, who will be talking about sports analytics and data science. Dr. K.N. Subramania sir currently working as a principal, RV College of Engineering, Bengaluru. He did his BE in Industrial and Production Engineering from Bangalore University, MTech in Industrial Management from IIT Madras, Chennai, MBA from Karnataka State Open University, Mysuru with HR specialization, and he has secured 5th rank in that, and in PhD in Supply Chain Management. He has total of 29 years of experience in teaching, training and consultancy, research and administration. His academic and research expertise includes operation management, supply chain and logistic management, e-enterprise modeling, simulation modeling analysis, decision science and applied economics. He has guided more than 100 UG and PG projects. He is actively involved in research, and he has also guided 4 research scholars. He has published 46 technical papers in referred national and international journals. He has also presented 81 technical papers in national and international conferences. He has executed several funded projects, consultancy assignments, and coordinating projects and consultancy worth more than 30 crores at our institutional level since 3 years. He has also authored chapters in 4 of his books. He is a member of various research committees, both at a national and state level. He has also served as a member of various autonomous committees in our country, serving as a member of professional societies including ISTE, BCIC, ORSI, IIMM, QCFI, IIIE, ISSE, CII, and CSI. Thank you. Thank you, sir.
Kindly pass on the share
Thank
to
you. Sir, I would request you to address.
can you just make the sir as a presenter? Vishwanath sir?
Can you please make sir as the presenter, sir?
Vishwanath sir, you can just right click on the surname and make as a presenter.
No, he's having some network issues, sir.
Oh,
If it is possible for you to make Subramanian,
yeah,
sir.
yes, fine.
Thank you.
Able to see the screen?
Yes, sir, it's visible.
Okay, voice is okay.
Yes, sir, it's
Okay,
audible.
so Elrigu Namaskara. Good afternoon to all of you. I'm sure that I'm standing between you and the lunch. So I will not take much time, not more than 15 to 20 minutes, so that we can close the function as early as possible. So I'm sure that since morning you have all listened to all the lectures related to the technology and to the management side. But I'm going to give a different flavor to whatever has been done. So I was listening to the speaker that he talked on the total engineering part of it, where a lot of data is captured for different applications. And you need a lot of hardware gadgets, and you need a lot of man-machine interface, and also a lot of technical details he has covered. So my talk would be on when once you use a technology, devise a machine, get all the things either using sensor or through any measuring instruments, you get that data. With that, what you are going to do is very, very important. I am sure that all of you are still in the mood of Olympics and the kind of medals we have got, and where we went wrong, and what should be our future course of action. And that is where the analysis of what has happened is very, very important for all of us. See, analysis could be done after the event, analysis could be done before the event, and analysis could be done much before you start practicing any of the sports or the games. So today what is happening is, as you know, that it is said that what cannot be measured cannot be improved. So that means sports analytics is one of the very, very important areas. Whatever my predecessors have done, I think it is one of the subsystems according to me. There is technology, there is a management, one of our alumni has spoken, and then this would be integrating this technology and management for measurement purpose. Because if you don't measure, we don't know where do we stand. In fact, what is the time taken? What is the time taken by a person who has a gold medal in the Olympics in the 100 meters? So it's a measurement. So like that, everywhere measurement becomes very, very important. Can you tell me any sports or games where measurement is not considered? You can look into all the list of items in the Olympics list. Everywhere there is a measurement. Either it could be the range of values, either it could be individual discrete value. So all these things are very, very important. But when once you get this measurement, what has to be done is very, very important. So what is sports analytics all about? It's a collection of relevant data, very, very important, and historical data. I will tell you why historical data becomes very important. And statistics, basically all these are numbers that can provide a competitive advantage to a team or an individual. Obviously, if you know the performance of an individual or you're an opponent in sports or games, I feel it will be very much helpful to you and to benchmark against the best in the world and see how you are supposed to improve. I think that's the way all the sportsmen and the people who play games keep this in mind. So that's how analysis of or the measurement in sports becomes very, very important. Fine. It will all be in 2 decimals and 3 decimal accuracy. You can imagine. Unlike other places where it's only integers, many places it's all in 2 or 3 decimal places. See, for a person in wrestling who got the 4th place versus the 3rd place, I think another 4 years it will be there in their mind. It was just maybe a point or a decimal through which they might have become the 4th place or the 5th place. So in that way, I feel analytics is a very, very important aspect for all of us to know. In sports particular, it is very, very important. So there are 2 key aspects you should look into it. One is on-field and off-field analytics. In fact, I keep watching basketball, volleyball, tennis, or could be cricket. And I find out even before the start of the game, there'll be a lot of statistics given by all these commentators. So it could be generally off-field analytics. That means the past performance of the people who are all participating in different things. Everything is already available. In fact, I had visited the Melbourne cricket ground in Australia, in Melbourne, and I found out there is a beautiful library on cricket itself. Anybody would like to do a research in the cricket data, I think that is a place to visit and get all the kinds of data you need, starting from when the cricket has started till date. They have all the kind of data and information available to them. So that is the historical data you can always try to get, which is an off-field analytics. On the field is again very, very important. I'm sure that people who are attending here definitely are the sports lovers. You will be seeing one way or the other on the field, because off the field, it is there okay. On a particular day, how people perform is very, very important. Let us say a first test against England, if you take, I think we would have won the match. That is our assumption, correct? But there is a rain. So on-field kind of a thing is very, very important. That is where your blood pressure and heartbeats would be very high. When you talk about the javelin player, when he was throwing the javelin, I think all of us were so much looking into that particular number, where he is going to put the javelin. So that is on the field. I feel off-field analytics is very much important for the sports person to improve, whereas on-field analysis as the spectators is very, very important for us. It is a different ball game altogether. Sometimes you may be watching online, sometimes you may be on the field. So watching all these matches, the kind of the sentiments, the kind of mind status of the people who are seeing all those things, then you'll feel what is analytics is all about. Fine. Let us say for last ball 6 runs. If you start measuring the heartbeat of all the people who are watching the match, you can imagine what kind of an analytics you can try to generate. And you can also find out the sports patriotism among people. So there are 2 key aspects, as I told you, on-field and off-field analytics. On-field analytics deals with improving the on-field performance. This is very important actually. On the field, what happens, because whatever you do in the practice session would be different from what happens on the field. Let us say you have players in a cricket and suddenly you come to know that the pitch is slow or pitch is a spin pitch. So on that day morning, you decide a lot of things to be done. Maybe you want to take 3 fast bowlers, instead of that you take 2 fast bowlers and 3 spinners. So that is how the things would be. So the on-field performance doesn't depend only on the player. It also depends on the lot of environmental parameters. It could be the most important environmental parameter would be the people who watch the particular sport or a game would be the most important. Weather would be another important thing which plays a very important role. So, and your mental status is another one on that particular day. So like this, lot of things go in the mind when you talk about analytics. So it's not just playing the game, but it has to be played with number, it has to be played with accuracy. That is how sports analytics is very, very important. So what all the analytics generally people do in all these areas? In fact, my student friend, alumni of RVCE, has told about the whole of the management of sports. I think that's where the whole sports market today, sports and games is one of the business sectors. Unlike previous times when only few people are involved, there's a lot of background or the other subsystems which are there in the whole of the sports industry. So understanding the sports market itself is very, very important. Can you have a total analytics on that? In fact, you can Google it. You can talk to the people, maybe people like say Decathlon, who sell the goods would be one lot of people. Other people who invest in the sports business could be other group of people. Other group of people who do only all these kinds of advertisements for sports. You can imagine there's a huge market, billions of dollars. I was just reading one of the very popular kind of sports market in US is the NBA, National Basketball Association. And after that, you have baseball, football, tennis, cricket, all the things are going to come. All these things are the different markets which people are looking at. So you need a lot of analytics even to understand the whole business sector. So that is where the analytics would be very much helpful. Another one is the ranking of the teams. How do they do the ranking of the teams? There's a lot of mathematics and calculation which goes behind. Let us say ICC declares who is number one in the cricket in a particular year. So who is the topmost batsman? Who is the topmost bowler? How do they decide that? Either it could be for individuals or could be for the teams. So ranking of the teams, again, there is a lot of analytics people have to look into because it all takes the past 1 year data on what all the games they have played, what all the sports they are involved into. Based on that, the ranking of the teams or the individuals had to be done. That is where analytics plays a very important role. Another one is predicting the score. I am sure that this is becoming very, very common nowadays. How do you predict a score? It is just like that you're making a gambling, because if you talk, let us say some 40, 50 years back, when the tools were not available, when all the statistics I was not in a position to put in one place. So based on their guesswork, people used to do it. But today it's not like that. In fact, if you would have watched the prediction of the scores in percentages versus India and England, they were giving 25% chances England will win, 32% chance India will win, and 52% chances, let us say, there'll be a draw in the match. These are all called as the prediction of the scores. Prediction of the scores is also called a huge area called forecasting. Forecasting is very, very common in the business field, but the forecasting or prediction is one of the most important analytical tool which people use in sports and games, which has got a lot of tools. In fact, if you put the past data in a graph sheet, then you'll realize what kind of forecasting method or the prediction method would be very much applicable. There is a time series models, there is an economic models. So there are a lot of other models which are available. And it is not just the models alone for prediction of all those things. There are a lot of subjective parameters also which are there, which adds on a particular day. So people use both qualitative and quantitative parameters to measure and predict the score. So this is where even the analytics would be very much helpful. Making a game, day decisions, day decision, that is on that particular day. What is the decision you are going to make? Also again depends on the statistics or the analytics, whatever you have with you. So I told you, it could be 3 pace bowlers and 2 spinners, or it could be 2 pace bowlers or 3 spinners, or maybe instead of 1 all-rounder, you may have 2 all-rounders or 3 all-rounders. This is on that day morning, people are going to decide. Of course, in individual games, it may not happen because it's only one-to-one kind of a thing. But in where the team sports and games are there, that is where making game day decision is very, very important. Nowadays, there are a lot of other people who help the players. There'll be analysis team itself will be going with them in any of the important competitions. So these people will give all the analytical information to them. See, this is what is this is what is all basically something called the what if analysis, which is very important in the whole of the analytics area. They do the what if analysis and then try to look into what should be your decision on a particular day. So decision could be certain, decision could be uncertain. You have seen many times that there is some decision which has been taken instead of a bowling, you might have taken a batting. but suddenly you may lose a match. That is the day's game decision what has been taken. So then next time that data will be there with you. Then you can make analysis and see that next time when you are making a decision, keep track of the last what happened, then take the future decision. So these are some of the on the spot decisions you may have to take also, wherein a lot of statistics will be very much helpful. Then crafting a message. This is a whole of your advertisement area according to me. You would have seen so many advertisements are going to come. I'm sure that today's sports and games, in fact, we always keep saying that in between advertisement, there is a sports and a games which is going to come. Nowadays, at least people used to wait for 1 over bowling. But even now, when the bowler is walking, there is an advertisement already. So you can imagine what a kind of field it is. The advertisements in sports, the kind of money which is involved is all in billions of dollars. It is a promotion to all the other companies, as well as promoting your own brands and the products. So crafting a message, doing the advertisement, promoting the brands. What kind of promotion of a brand you are talking about? You see the, I take cricket only as an example because I generally watch this, that you see a t-shirt which is worn by either Dhoni or Kohli or Jadeja. You can see how many companies are there in that. You just take the hat, the helmet in a cricket game. There are a lot of advertisements. So branding has happened to the core. Before, what used to happen, one brand, one t-shirt means only one company used to be there. In fact, now you can ask a quiz question that in a Kohli, when he's wearing a shirt, t-shirt for the match, find out how many companies are there in his t-shirt. That's the way the branding people are doing, because they know that if the important people in sports and games wear it, youth will get definitely attracted. The sales of the other products will also be very good. So that is where a lot of analytics is available. Branding, products, messaging. Messaging is a text analytics basically. So there is a text analytics, there is a number analytics, and there is a video analytics. There are a lot of kinds of analytics which people try to do it. Video analytics is one of the latest areas which people try to use. Can you do analysis? I'm sure that you would have watched when a third umpire says, okay, it goes to the fourth umpire for decision making. That's where video analytics is going to come into picture. So, and all these are already available to people. But what goes on in the background? I think there's a lot of mathematics in it. There are a lot of statistics in it. There are a lot of good people who are having a background of all these things will be working at the back end, which people may not know. Fine. Then growing revenues. There is a lot of analytics which you can look into it, because what is this revenue all about? Let us say you take IPL matches, the kind of investment each of the team does, they look at a lot of revenue also. So I put, let us say 20 crores, how much back I'm going to get. So this kind of a break-even analysis, or what is your revenue generated, there are a lot of analytics which people try to do it. There are a lot of financial models which are involved in all those things, the break-even analysis, profit volume analysis. A lot of analyses are available at the back end which people try to work with. And of course, managing finance is very important. This is very important when you talk about, let us say, IPL. I have only 20 crores. When I'm calling for the auction, how many I should select? Who all the player I should select? I think that's where the managing finance could be understood very well. 20 crores. What do you need? There's a lot of analytics, the background people try to, there's a huge team who tries to work for that. So then playing what if games, as I've already told you, I think I've already explained to you, what if games is nothing but instead of a fast bowler in the first over, if a spinner goes, what is going to happen? So there's always a what if analysis in every game, If I'm aggressive, what is going to happen? If I'm defensive, what is going to happen? So can I be random in my thoughts? Something is going to happen. In fact, there's a beautiful story of Kasparov and Karpov in chess game. They say that Kasparov is a very, very systematic and a textbook kind of a player, whereas Karpov is very randomly, he thinks and makes a move. So if you make a random move in any of the game, the opposite party gets actually affected. So they say that that's how the Karpov used to play. So like that in many games, there could be a random behavior, randomly people can look into it, or there may be a systematic textbook kind of a game they can play. So all these things could be studied with analytics, what kind of a thing which people can look into. In fact, there was a very interesting game in Sharjah against India, Pakistan when they were playing. Actually, Srikanth, as you know, that he is a person who brought during the first overs to play 4 to a fast bowler. And of course, Gavaskar and Srikanth were playing, and Gavaskar was playing defense. And in one game, Srikanth was going on hitting. And then next, when Gavaskar came, then he also started hitting 4. So then Gavaskar told Srikanth that the way you are playing, it is very, very easy to play even for me also. But if something wrong happens, I think team is going to lose. That's the way it is. So a player will have a status of mind, mindset would be there, and they'll be playing based on that. If you want to change that, it's called as a randomness, which may work sometimes or which may not work some other time. Maybe for Srikanth, it may work all the time, but for other players, it may not work all the time. So that's the way it is. So what if I take this kind of a decision, it is very, very important. You should know. In fact, I can go on giving a number of examples. There are people who have won the matches. They have won the matches with all these kinds of analytics. Okay. Then working with sports data. So there are a lot of companies actually have started now. As my predecessors have told about the technology involved. In fact, I'm sure one of the most important technology which people are talking about is the sensor technology, IoT. Then the way where you hit in a bat. So what will be the analytics? Can I have that data through a sensor and collect it on common place, send it through a cloud, put it in a software, try to do the analysis. All these things, online real-time analytics are possible. So, and then finally competing on analytics alone basis. There are certain games and sports where just numbers, with numbers people are going to play. There are certain things where psychological games are there. There are certain things where psychology or the behavior as well as the number, both are going to play. So when you try to look into these things, I suppose these are all the areas which I could list some of the things where analytics is going to play a very, very important role. And I'm sure that whatever the games and the sports you people are playing, just look into all this data and look into the analytics, whatever they do, then you'll realize how important it is. I can give an example. Last year, I guided one bunch of students in my college. They were all representing the sports in my college. One person was a table tennis player. He was playing for the country nationals. Other was a swimmer who was actually represented India in the Asian Games. And he got, I suppose, 7th place. Okay, there was one more player who was a shooter, and all these 3 players have got Ekalavya Award in the state of Karnataka. And what I did is I called all these 3 people and asked them to make a group and do a final year project. Otherwise, one person is in aerospace, other person is in industrial engineering, other person is in mechanical. They would have done a different kind of a project. But I took some innovative idea and asked these 3 people to join and do a project. You know what was the project? How the technology could be used in enhancing your sports. That was the title I had given. And then what had happened is a swimmer who represented Asian Games. I was asking him, you tell me what is critical to winning in a swimming. So then he told, because in swimming again, it all happens in seconds and microseconds between the first and the second place. So then I was asking him, he was telling, sir, that we get ready for swimming and the way we jump, the way we move our legs is very, very important. Some people take a long jump. Some people will take a short jump. It depends on the against the gravity, how fast you can move. He was telling that the movement of the leg during the last moment is very, very important, because a person who takes the long step, he definitely has a chance of winning, because he will be always certain meter distance away from the other person. So then I asked him, try to study that particular environment, use analytics and try to see how well, in which position if you stand, what should be your physiological way. In fact, one of my previous speaker was showing that bio-inspired kind of a thing. In fact, people can take all a cheetah as an example actually. So cheetah as an example, if you take care of it, then you know how fast it jumps. So like that, biomimetics is also order of the day. Watch the nature, watch the animals, watch the natural things which are available, then it may also be helpful for you in your own sports. So I asked this person to study about that, and he took all the video analytics and then tried to observe, and he told it has helped him a lot. There was one more person who was playing table tennis. So in a table tennis, as you know, where do you hit from a bat to the ball and goes to the next person? What should be the optimal position in the bat? Then I asked him to put a sensor for the bat and try to see, and he got a beautiful analytics on that. In fact, after that, he used that same analytics and he won some games also. So that is the way, if you try try to make use of the technology as well as the games, technology as well as the analytics. I'm sure your apart from your, of course, routine practice is very, very important. Apart from this, if you do it, I think chances of winning would be much higher, because we deal all these things as a separate thing. Technology is separate, analytics are separate, your way you play is different, your behavior pattern. So there is a common point of the integration you're supposed to do it. Then it's going to be very much helpful. And there is also one more player who was a shooter. I think, I don't know how many of you know, in shooting, there is huge lot of technology which is involved. The person who shoots a particular point, there is a lot of, in fact, that player, Tejas, actually, he runs a training center in Bangalore. And I visited his training center. He was telling me that the kind of coordination between the hand and the mind is very, very important at that particular point of time. If you just deflect a delta X, which is not even 0.001 mm, the head movement and the finger, then you will not hit the target. So there are a lot of videos you can take it, observe what is your cognitive part of the mind during at that time, along with your physical movement can be managed. This is a total video analytics game. So I asked all these people and make a case study. In fact, we are also publishing that in one journal also. So like this, I think if many of your engineers here, you can also look into that how can you integrate technology with this and try to generate analytics so that your performance would be definitely measured by yourself in the beginning, then you can do better also. So I think these are some of the areas. I will not go into the details. I had a lot of, I had for 45 minutes, but I don't want to take much time. These are the data science methods which are used at the back end. A lot of things will happen. There's a social network analysis, data visualization, regression and classification models, because you get so much data, you're supposed to classify also. So then looking into the data mining and the machine learning models, sentimental analysis is a very huge one actually, very interesting analysis. Then as I've already told you, can do the forecasting or prediction. You can do the market response models, the time series models. All these are the data science methods people use to model the whole of the data and the information, whatever they get from the actually the sports and the games. And of course, if you take the model classification, always happens like this. The real world, the human is a part of this modeling. The operational thing, whatever you do, and the gaming, what you do is a human part of it. That means your practice, your way of game is your own. It cannot be depicted from others. So you should be on your own. But external to human for a modeling process is something like this. So if you go to the from left on the x-axis, increasing degree of abstraction and speed is there. And in fact, if you go to the right, and on the left side, if your model can be designed to the left side, which is totally as a part of the human, then increasing degree of realism and the cost would be a most important factor. So this is briefly, you can look into it. There could be a simulation models or analytical models which are used for the analytic purpose. Modeling process is external to the human when you talk about the softwares and the sensors, whatever you use it. But as a part of your human effort is very, very important. I think that's a topmost priority. But analytics and other things will be helpful to you for bettering your performance. So this is the whole of the modeling classifications. I'm not going to details of all those things. So only thing you should know is that in the mathematical modeling, you have on the first column only, I will not be explaining any other things. So what has happened is a descriptive. That means the past statistics, you can have a descriptive analytics. Then what could happen? It's a predictive analysis. What can you tell me tomorrow who is going to win in the match? That's a prediction you are going to. What could happen? Prescriptive is what should we do? Prescription has to be given. So that if you do like this, this is going to happen. It's called the prescriptive analytics. So these are the three types of analytics tools which people use: descriptive analytics, predictive analytics, and the prescriptive analytics. It is apart from a business, it is applicable to every field where the data and information are generated. So I hope with these models, you can try to do it. And of course, people have already started using the machine learning algorithms and the AI models, even for all these sports analytics also. And the reinforcement learning. I am sure that people working at a very high level of sports analytics will be definitely using the machine learning models. People who predict in a better way who is going to win. I think these people will be definitely using machine learning and AI models. So these are some of the analytic tools people are going to make use of. There are a lot of things. I just given a tip of an iceberg, that's all. But I feel that analytics, what cannot be measured cannot be improved. I think that's one of the most important thing. A gold medal winner of 100-meter Olympics, he is around 8.57, means if somebody gets 8.55, he will be the gold medalist. The difference between the silver medal and the gold medal, silver medal and the bronze medals is very, very, very less. I think that is where people have to give value to the analytics and try to understand. You cannot just neglect it and say it's okay, let us look into that. So, but if you know these factors, who are your opponents, what are their strengths, how can you improve on the analytics part? If you have all this study with you, then your performance would be much better. There's also something called the negative side, analysis paralysis. So you cannot do too much analysis also. Your analysis should also be optimal and should be realistic. So if you can make sure that, I think this will be very much helpful. Maybe we are planning in the next syllabus revision as for the new education policy, we'll be introducing, let us say, sports engineering, the sports analytics as one of the electives. For the students who are into the sports, can definitely take those electives and try to do it. And we have a lot of sports data in the college of our college, RV College, starting from Anil Kumble to Chetan Babur to Vinay Badami to Avinash. You take, there are a lot of sports persons representing the country in our college and the state also and the university also. So that means if all these youngsters start working with analytics also, your performance would be definitely much better. And any kind of a collaboration, if people wants to do with our college in terms of the IoT, sensor development, then any development of a gadgets for measuring some things, we'll be very, very, very happy to associate. Once again, I thank my sports department for giving this opportunity, along with Sports Engineering Association, SCA India, for jointly organizing this program. And I hope I made some sense in the time, whatever is given to me. Thank you very much. If there are any questions, we can take it.
Thank you so much, sir, for the valuable information. We have got the overall view about how the sports engineering technology and the management works. I hope everybody had a really good session from the morning with all of our speakers and the chief guest. I would also like to thank the sports department of RVCE for giving me this opportunity to be as the master of ceremony for this event. Now I would like to ask Dr. Vishwanath sir to go ahead with the vote of thanks. Thank you, sir.
A very good afternoon to one and all. I, Dr. Vishwanath CN, Director of Physical Education, RVCE, take this privilege and honor to propose the vote of thanks to our esteemed speakers. First and foremost, I thank RSST for giving permission to organize this national seminar. I thank Dr. Pintu Modak, Senior Physical Education Officer and Secretary, Sports Engineering Association, India, taking his time to enlighten all of us. Thank you very much, sir. I thank all the esteemed speakers, Mr. Anil Kumar Suravaram, Managing Director, Great Sports Tech, Hyderabad, Professor Manishankar Dasgupta, Professor in Mechanical Engineering, BITS Pilani, and a President of Sports Engineering Association, Dr. KP Venkatesh, Assistant Professor, Mechanical Engineering, BITS Pilani, for taking the valuable time and enlightening all of us with the most dynamic topics, sports surfaces, technology, biomechanics, and sensors. Sir, on behalf of RV College of Engineering and Department of Physical Education and Sports, I think this is a privilege to thank you for your valuable time, sir. As we are all learned how the surfaces are available and make use of it, technologies, biomechanics, sensors used to improve the performance of the sportsman. So you all have dynamically enlightened all about the sports engineering technology in each and every slide. Thank you very much, sir. I take this opportunity to thank our alumni, Mr. Rajesh Javalkar, for taking his valuable time to enlighten the sports management, how to adopt it in the institution. Thank you very much. I thank our beloved principal, Dr. K. Subramania sir, who supported us in conducting this mega event successfully. My special thanks to Major Raghavendra sir, Dr. Mallesh, Srimati Meenakshi, for Shivamurthy and Prakash. I thank all the HODs, staff members and sports committee members to make this event a grand success. Last but not the least, I would like to thank our volunteers, Rakesh R, Rakshita Sharma and Nakul RS and Kaustuba PB for their continuous support to organize this event in a grand manner. I think we have already posted a feedback link. Just fill the feedback link, and also you will get a participation certificate by today evening. So I think apart from this, thank you one and all.
Thank you all, particularly the speakers, Sir Venkatesh Rao, Manishankar Das Gupta, and Rajas. I thank on behalf of the college for accepting the invitation and to be here. So let us be in touch because we would like to do something in the sports engineering. We'll get back to you, sir. Thank you.
I thank one and all for coming here for the seminar. Thank you.